today morning's keynote, that is by Professor Shantanu Chaudhary. He is from IIT Delhi. The title of the talk is Document AI Perspectives and Future, and I would say uh, this is the really most qualified person which we are having to speak on this topic. Um, Professor Shantanu was the consortium leader for the MIT project group on um, robust OCR development, and so that gives him immense qualification and background to be speaking on this topic. So some more formal introductions, like he did his BTech in 1984 from in electronics and electrical communication engineering, and his PhD in computer science engineering from IIT Kharagpur. Uh, Presently, he is a professor in the Department of Electrical Engineering at IIT Delhi, but previously he had a term as a director at IIT Jodhpur. Also, he was a director at the CSR Institute, which is on Central Electronics Research Institute, and he also served as Dean Undergraduate Studies at IIT Delhi, and he has held the a number of chair professor positions at IIT Delhi. In the awards, he has been awarded the INSA Medal for Young Scientist in 1993. He was a fellow of the Indian National Academy of Engineers (INAE). He's also a member of the National Academy of Sciences (NASI) and International Association of Pattern Recognition. He's a fellow of the IAPR. Um, he's also a recipient of the Distinguished Alumni Award from IIT Kharagpur, with over 350 publications in reputed journals and conferences, 15 patents, with technologies commercialized by global industries. Certainly, we are very happy to have him here. His um, research interests are in computer vision, AI, digital heritage, AR, VR, and multisensory media. Okay, so
Good morning. I think we are delayed, but I think for circumstances beyond our control. Uh, okay, I think I've slightly modified my topic in the sense that document AI, and I'm really talking in terms of document analytics. And document analytics in a more generalized sense, because today, if you see, we talk about analytics, we talk about data, and we typically look at data in a very unstructured way. Document is also unstructured, but document content has an inherent logical structure which comes from our compositional principle. So it is not just random data. So if I take a experiment and just doing a measurement, we are getting a sequence of data, but there is no logical structuring of the data other than the fact that they are outcome of an experiment. But when you look at a document, the basic content may be in that sense unstructured. It is not tables, but it has got a logical thinking which has gone into it. So it is in some sense structured. So now how do you, therefore when I talk about document analytics, it is not just interpreting the data in the document, but also to interpret the logical structure which has gone into construction of the document. Therefore, the problem is of a different kind than that of standard data analytics problem. So I shall try to address that issue, and that also is a very interesting area altogether. Next is, yeah. So let's try to define what do we mean by document. A document, that's why this is a generalized definition of a document. A document is a written, can be drawn, can be presented, or memorialized representation of thought, often the manifestation of non-fictional as well as fictional content. Okay? And content in different forms with a variety of layout, sequence, and attributes. So this word, if you see documentum, or that is a Latin word, denotes a teaching or lesson, and verb docio denotes to teach. Therefore, there is an inherent communication in the document. And contemporarily, document is not defined by its transmission medium, that is paper. Its existence can be completely in electronic form also. And document also derives importance in the context of other documents. So it's a connected world of documents. If you see and if you look at, when I have a library, library is just collection of documents, and it's not necessarily a connected world of documents. But when we actually do a library work as a researcher, we create a connected picture of the set of literature for our purpose. So therefore, document has got that connection. So it's not document analytics, is not necessarily a single document made stuff. So connected documents have explicit or implicit connections. So this exactly gives me the point where document AI is more than data analytics, more than document analytics per se, is that refers to use of technology of automated extraction, classification, cross-linking, and understanding of information with presentation formats, that may be from web pages, maybe from digital bound documents, maybe scan documents, or multimodal interactive documents. So therefore, if you see today, our space of documents and the way we create and express our creative thoughts or scientific thoughts, that medium is large. And if you look at this collection of our thoughts, and I want to distill out of that collection and want to process and present, that actually is a problem of a different kind altogether. So therefore, different kinds of techniques comes into play: signal processing, computer vision, natural language understanding, multimodal data analysis, and analytics principles. And in fact, it's very, very important to see that classically document analytics, you will find that refers to using document image understanding, which was actually a computer vision problem. But the moment you look at it and where it is moving today is actually a much more generalized and much more challenging problem. Okay? So automatically reading, understanding, analyzing, linking documents, that's exactly what is very, very important and critical. And multimodal document is today a very important and significant data component in our world of any kind of academic activity. Yeah, so if you see, these are all examples and of documents, but what is important I want to show is that if you look at one level, those who are doing earlier document image analysis, the problem is that of analyzing the layout. But these documents cannot be understood if I don't have a background knowledge. So therefore the background knowledge and how we incorporate and put in the background knowledge for its own understanding becomes a critical component here. Because I do not understand, if you see, this actually is a big problem if you look at today is being talked about, contract management. If you look at from an industry point of view, there are lots of big industries are looking into how to have their contract database, how to synthesize a new contract for a customer which is consistent with the government policy, and how the contract clauses can be also specific and hidden. So now if I have a contract, then I need to understand the contract and then generate a contract from that contract. So it is a purely commercial problem, but there are huge technology challenge because you have to understand the contract, that's a interpretation, and you have to generate a contract, that's a problem of generative AI. Okay, so therefore the document analysis, that's what I want to show this example as, that it's actually spans across the entire range of intelligent technologies that we are talking about. So therefore it can be structured tables, processing documents, there can be approaches for sales data analysis, therefore it's a table analysis. Today if you see that there are completely a range of papers which are coming out, technology which are coming up, which are dealing with tables in different form. We see PDF tables, but you give those PDF tables to a computer to analyze, it's not easy. Okay? Then you see the semi-structured records, electronic health records. Electronic health records has variety of things. It will have handwriting, it will have structured data, it will have image. And if I want to do any analytics based on electronic health records, the first step is I need to have the ability to understand the record. Okay? Then there are organized data collections, say for example scientific publications, legal case files, news, social media. In fact today I think the current OCR project which is going on, a major objective is to actually look at and understand parliamentary documents. The documentation of parliaments and state legislative bodies have used huge document data. Now any reference to a parliamentary bill which comes, it has to refer to past bills. The whole thing happens manually. But today, with so much data, see after 75, almost 75 years of freedom and constitution and everything, the volume of documents somebody has to go through is humongous. And without digital technology, nothing can happen. So all of the assemblies now are looking into digitization of their documentation, indexing and a search mechanism. And that's also a very interesting problem because this also opens up commercial possibilities. Because each of these legislative assemblies, state assemblies, they do their business not just in English but also regional languages. Okay, so therefore, how do you actually interpret regional language legal documents and tell that whether there is a precedence, there is a violation, everything. If you see even Supreme Court, there has been contradictory decisions with reference to not being able to refer to correct precedent case decisions. There is documented evidence of that. So it's actually a very important and critical component of even continuance of governance. So therefore, these are all kinds of problems which you are there, and these are all originates from this domain. And if you look at labeling challenges, universal representation of heterogeneous inputs, knowledge constrained interpretation of contents, domain transfer, explainability, and possible bounds of error. In fact, these two parameters are extremely important to build what we call dependable document analytics system. These issues we have never addressed before, because now when we are talking about referring to a court case or a parliamentary bill, you have to make sure that you are not making errors, if you are making errors within a bounded probability. And there are heterogeneous types of documents and structure and semantics. The interesting part is, if you say NLU, a natural language understanding, the natural language understanding or the interpretation of a language construct is actually a sequential data. In natural language understanding, the format of representation is not there. Today the entire LLM, which has come up with your generative models and ability to model language as a huge autoregressive structure, and based on that you interpret and you generate, in that whole framework, the representation or the formatting or structuring of the language constructs is not there. But when you read something, the structuring is also a very important element to understand and interpret. So this is today's bottleneck or the gap in the natural language understanding. So this is an example. So look at this document. If you give this document in electronic form to LLM, what it will do? LLM doesn't understand or interpret this layout. Okay? This layout is a critical element of these if it has to be used for any purposes. And if you see, there are text reconstruction with the layout, so therefore there are different parts and different problems. If you see, and if I have to interpret them, these are all, if I say that what is the date on which this was generated, then I have to interpret the box, and based on that I have to give the answer. I have to interpret the layout to get the answer. So I have to do the layout analysis to get the title. And I need to do possibly masked image reconstruction to find out the shipping date. So if you see, just interpretation of these simple an invoice or a receipt requires to solve vision task. If you have to solve this mixed task, okay, the layout as well as the vision, then purely text task and purely layout task. So a simple receipt in digital form, or even just an invoices which are maintained in digital form, if it is to be interpreted, simple natural language understanding doesn't do the job. It has to be a multimodal. So these are other examples. If you see this form, if I have to interpret the form, say medical record, the form and there are different data, and these can also have, this is printed, this can also have handwritten. You have to identify the field and say and know what it is. So the key point here is, given if these are the fields, I need to know the semantic entity recognition. This problem is that of semantic entity recognition in a structured document, where all of this knowledge is there. And if you see, this is a content analysis in different forms. Different types of tasks present in document images that we need to address. So obviously this is much more generalized way to look at things, and particularly if we look at historical documents, the challenge with handwritten text, challenge with noise, and this is completely unstructured. How do you interpret this? How can computer extract information out of this? So you have to go through, if I am looking at newspaper records of last 50 years to see how things have changed, any analytics, okay? So for example, there are lots of issues now coming up in terms of different subcasts, caste and their growth and their potentials. These are all politically very, very sensitive issues. You have to do a kind of an absolute objective analysis over 50 years record, okay, or even more than that, and what has been reported in newspapers and other government documents. Now, why I am trying to establish all of these is not an esoteric scientific field. It is a field which has got tremendous practical applications, even business potential. So there are so many young people. So I think they should look at and think about those things. Now the key technology today which is coming up is also in a way has got aligned with the development of these LLMs and chat GPT and that's what is the key point over here? The key point of this technology, if you see the attentional models, the transformers, okay, and this self-supervised learning. Now if you bring all of this together in a different media form, these are the key techniques which are being used here and has to be used here in an intelligent way. Okay? So that's exactly what is being done today to have this whole thing be worked out. So if you see generic document, if we now look at, try to think in terms of, we use what? In language we use pre-trained models, we fine tune and use it for different applications. If it's a foundational model, we shall use a prompting, that is in context learning, to get things done. Now this document image understanding is also has moved into this process of system development. Okay? And if you look into that, if I look at pre-trained model, if I want to generate pre-trained models, so these are these kind of, I can have these multiple pre-trained models. These are different conditions, okay, so I can do semantic entity recognition, entity extractions, and we can look at both structures and unstructured handwritten text. Then we can look at document classification, we can look at noise removal. Now, what these are showing you, just like a foundation model is trained with huge number of data, okay, huge number of documents or data. In document image space also, we are trying to talk about that we shall deal with different kinds of tasks. A foundational model gets pre-trained with multiple tasks and then you tune it, so then you can use it for task level applications. Okay? So the architecture, the way we are talking about today, I think we are familiar with the multimodal systems. See, multimodal foundational systems, and if you look at from their architectural pattern, this document image understanding is actually an instance of that architecture. That's what we have to build. But there are not many things which are really available today. And all of us know say BART. BART model can be used. That was essentially, if you see the mask language model, it was, and from BART to BRT BART, which was more auto-regressive. But look at BART. BART was simply a mask language model using self-supervised learning to learn the language semantics. The question is, now can I extend that model to learn a form semantics? Okay? Because I can mask the field and then try to predict the field depending on the data. Just like I do it in a language, that is I have a sentence collections and there I mask the words and learn to predict the words and that gives me the relationships. And that also defines my attentional models. Fine? So now that's exactly what we tried to build this kind of vision language transformer models. There are people who have worked on it. So these are masked OCR tokens. OCR will have huge contextual values. Okay? So I can have masked OCR to train the OCR to do correct predictions. Okay? So masked OCR training. But masked OCR, if you say Indian language models, the characters are not one dimensional, but they are two dimensional. Okay? So you have to look into kind of a 2D embedding absolute position and relative embedding. This is actually how do I construct the embedding for these kind of masked OCR tokens. Okay? It has to be 2D embedding box, that relationship. It's absolute position embedding and relative embedding. Okay? So I can actually represent all of these with respect to a representational space, just like we do a locational data gets associated with a feature token I can do this locational data, but this locational data becomes much more generalized. And then if we look at how do I train? So I have these masked OCR tokens and I have these masked bounding boxes. Now why OCR tokens and masked two bounding boxes? Because OCR is a character prediction token. Okay, I'm learning to have the characters. If I know how the characters come one after another, that is the masking part. But also I need to know the word layout with reference to the document layout. So that's why masked bounding box. Okay, and to this we have combined image features, which can be also connected component. In fact, image features, because image features also tells me if there is a mixed document, okay, where images are coming at a particular point, then I have a prediction model. See, what does really BERT do? BERT use a bidirectional prediction. Okay, it is not LSTM. LSTM requires what? The immediate state, previous state based recognition what is happening, and we have done these OCR applications in terms of bidirectional LSTM and which has produced results. But now you are actually OCR, the character is requires a more longer predictive model to get the correct prediction, because I need to know the word is contextualized with respect to other words. So therefore, in a language model, you will do a word masking of the words. But when I am doing the character recognition for the words, I have to mask the character with reference to the word. Okay, so therefore I am doing therefore this is a masked OCR tokens, okay, masked bounding box tokens, because that's giving me the word boundaries. Okay, and then I have got the image features, because image features can actually give you that if it's a shaded area, then how do I use the image features, and based on that I can do the predictions. Okay, so what I'm trying to show is that the way the vision transformer works with the visual features or video features, I need to look at today a document image analysis or document analysis for that matter, a kind of a transformer architectures, and learning these predictions, which really gives me the attentional models to understand the semantics, and based on the semantics to do generation. Okay, so these are, and there is a very nice, this FunSD data set on which you can work and get, and we use these and we got some sort of results in that space. This is a paper this year's IGDAR that where we got this work reported. And if you see, there are also qualitative results, because this, on the basis of predictions, if you see, there is also distortions. Because of the predictions, I can actually do correction modulo the distortions, because if I have this set of documents, I have the model of distortion. I'm not mathematically pre-modeling the distortion, I'm learning how to correct a distortion on the basis of prediction models. So these are all classifications of different data and what we have done, and this is, if you see that, so what I'm showing here is not only just prediction, but using same model, I can also classify the documents. Okay, so now I generalize my attention model, and I define my attention models not just with the box, but also the connected components. Why connected components are important? Because when I'm looking at an Indian language recognition, I have, say, the joint characters, conjoint characters, we have these matras. These are all connected components and two-dimensionally connected components. And if we can define an attention model on those connected components, I actually learn the context. Attention models are nothing but context, because of which I can do a better language modeling. Here what I'm trying to say is I am doing a better the script modeling, that is handwriting or a printed script in different language, the modeling bringing in that context. And that's the most interesting part in terms of, if you see that embedding and this attentional model is now being used for all the media. Starting from, it started with language, it's being used in vision, it's being used in speech, it's being used in other signal processing tasks, and in the similar way, it can be used for this kind of document image analysis, handwriting analysis. Only thing, the primitives that you use are different. Your attentional space you need to define appropriately so that to get results. So using, we had actually handled complex layout and other stuff, and using this kind of, with this multi-headed connected component attention and multi-headed connected cross component attention, and building up this transformer with the connected components and using multimodal attention and get a better interpretation of results. So this is the architecture that we use, and because the ground truth is not there, so in many cases we used unlabeled data set to train on the basis of self-supervised learning. So if you see to it that if this is a kind of a complex layout, and this is can be a language independent kind, this is a data result from a Bengali document, this is a result from a Oriya document. Okay, so that means this can be a language or script independent technology can be really developed around this core concept. So these are quantitative results, and it's basically, if you see that what is the state of the art and what we have got. So now people are working on Doc AI foundation model, and Microsoft has worked, and in fact 2024 paper is there, that multimodal document foundation model layout XLM. This is for multimodal pre-training for multilingual visually rich document understanding model family. And I think the question right now today is, we possibly need to work on creating foundation model for Indian language documents, handwritten styles for multiple tasks. Because what I have shown is that this kind of pre-trained models and fine-tuning are feasible, and it's possible for analysis of that. And I think today this, I do not really, this Bharat, that model which is this Bharat LLM, that project which has initiated, whether they are looking into handwritten. I know they are looking at Indian languages, but document I'm not sure whether they're doing it. But if you see, this is an interesting architecture. This is multimodal transformer encoder layers with spatial aware self-attention. What I was talking about, okay, that actually has been now expanded. So our paper was this year's in IGDAR, and this year in 2024 archive you will find this Microsoft, this foundation model in document. So this is really coming up in a very exciting area to look at. So if you look at intelligent document processing, these are all different components which comes up, and these are got associated. And why I wanted to show this is also, even the commercial entities are showing that this cumulative growth rate of about 35.28% during this period, because this is a commercial possibility also. So it's not that pure academic research. There can be lots of, maybe 10 years back or 20 years back when we started doing OCR, these commercial possibilities were not apparent. But today it's very clearly these consultancy companies are predicting these commercial possibilities. See, tabular content analysis and table transformer is one, and this is actually a work that we are doing. I have masked this out because this is for an industry that we are doing right now, using the tabular data and basically trying to use the tabular data based kind of a pre-trained model and use that for different commercial tasks. Particularly getting, say, customer data and using the customer data, how to use it for, because customer data comes in various tables and we need to deal with those tables. Okay, and based on that, if I want to do a campaign, a marketing campaign targeted, I need to understand the structure of those tables, the components of the tables, and how do I synthesize a campaign based on those tabular data. So using table transformer as a basic building block, and also what we are trying to do is that a kind of a federated model, because I have tabular data from multiple sources, and have a federated model based on that trying to generate a kind of a campaign, a marketing campaign. So this is what we are trying to do with one of the industry. I thought that let me just touch upon it, because this is again a document data. This is a tabular data, is essentially a document data, but just look at it that using data in Excel, okay, the structure of the table is being exploited, not just the data sequence. So therefore, there has been various approaches. This is one of the earliest work which has happened, and I think I just referring to, and then you can have document processing over there. And okay, this is there is a problem here, I think. Okay. Okay, so let's look into the consumer tools. That this is kind of a today. I think number of state governments. This is again something which is coming up in a very interesting way. Number of state governments today are looking for this automated correction of examination scripts. And if you see today, your CBSE use a computer-based corrections. They scan the documents, and scanned documents comes to the school, and the teachers go through the pages and give marks. So I think there is a huge interest across to automate that process. Okay, and if you even if you can do semi-automation of that, there is a huge market for it. In fact, they are actually looking at. I know of at least 2 state governments have actually asking for proposals to look at that. So these are not. So now let's look into that information extraction. We just talked about the processing, interpreting a document. Okay. Now interpretation of the document is not end of the story. Interpretation of the documents is the starting point of the story. The more important aspect of the story is extraction of information from the document. It can be extracted from a single document or document of documents. This is something very, very important, or document of documents. So therefore, extract insights from document repository or extract information from a single document. And if you see all of these, say multi-document summary, how important it is, let's say policy matter, all news related to Delhi pollution 2024, not 2204, but 2024, okay. And then question answering from medical literature, common causes for heart attacks in young adults. Because we have seen in recent times number of reports of young adults losing life because of heart attack. Now if I have to do an analytics on that, I cannot search and do it on my own. A medical informatics required to have techniques to unearth this data from variety of sources. So all of these are actually problems of document analytics. So if you see, therefore now NLP has to be adapted for document analysis. What we are talking about in fact in terms of a standard NLP, and what LLM does simple query answering on the basis of what it has got from the data that it has got, that it's there. But now it's not task directed. So what I'm trying to stress upon is where is LLM today and where is the gap based on what is required. So LLM is not the ultimate thing in terms of natural language processing, so we should keep our hands closed and stop doing any work. That's why this document analysis is very, very important, because document brings in structured data, structured linguistic data, and we need to have the ability to interpret and exploit structured linguistic data. So therefore, if you see linguistic analysis, you can always do. These are all tasks and which are there already happening. Now you want to do statistical reporting on all of these, and also you can have a variety of generative applications around it. And what is natural language inferences is conclusion. See, LLM gives report, doesn't give inference. Because LLM can also hallucinate. There is no validity in terms of natural language inference from LLM. Because that's exactly another open problem to look at. So therefore, all of these are important and to look into it. So you need to have, these are the challenges over there. Okay, if you see custom NLP components needed large volume of annotated data, handling non-uniform structures, multilingual code mixed content, domain customization, and generation of text, all of these in terms of directed way, none of these LLMs can do straight away. Okay, those who are familiar with LLM, you can very clearly see that they cannot be done directly by LLM. So what I'm trying to say is that I shall show that LLM as a component. Okay, if LLM is available, because see the point is I cannot generate something equivalent to LLM because I don't have resources to do that. I have not been able to say, I cannot go through the entire internet or entire libraries, but people having lots of money can do that. If people can do it lots of money, then how can I build on top of those money? I should have the intelligence to exploit that money, okay, in terms of technology and technological innovation. So there are a huge number of problems which we should look at and not say for everything that LLM will do it. And this is actually also another problem that when you go anywhere, experts, we are also belong to some of those categories, but they say LLM is doing, why do you propose such a problem? Okay, this is something is a major problem today. We work with half knowledge. So if you see that there are now LLM are one-stop shop for all of these, fine. But there are many problems that I've highlighted in the previous script which can be addressed once you have this one-stop shop with us. So this actually generalizes the whole definition of document. Say delegate your NLP task to ChatGPT. That's a standard thing we do. Say for example, a restaurant review analysis, and it can be conversational, that is summarize the above, so you can have. So this is an advantage of what LLM can do, what LLM is doing. Now look at this. Using LLMs instead of customized pipeline has all these benefits today. And that's why it actually is so popular and useful. So this is something we need to understand. If we understand this, then we know how to exploit it. So therefore, if I do this kind of document repositories, you set up tasks, map to features to be extracted from tasks. This can be done through LLM. And to do this, you actually do a prompt LLM, output in a structured format. Once you get that output, you can create a database, store output in database, analyze and generate reports. So therefore, this point is what LLM, I am exploiting LLM. Post this, how do I database, analyze and generate reports? This is what I am doing using an intelligent, maybe knowledge driven system and using LLM as a component. This becomes a kind of a generic architecture. If I have a document repository, I can analyze the initial phases of the document repository analysis. These are going through the LLM pathway. Post this, I can have my own pathway and add value to this. So using LLM as a component. So if you look at LLM, this with small contexts, LLMs are not best tool for count, sums, average. This kind of statistical insight generation. LLM cannot do that. And also, if you say that, this is an example, there is negative sentiments. How much of negative sentiments? LLM can give these are the negative things, but what is the frequency? How many negative sentiments it's coming out of it? Okay. So these kind of quantitative analysis, the analytics of what you are seeing is not what LLM is providing, so you can use analytics out of that. So aggregate analysis happens outside, and this is where is an application, the simplest possible application you can build around LLMs. Now once we have this, there can be also lots of, I've done a jump over here, but showing that this is an aggregate analysis. If it's an aggregate analysis, now look at this library science. So library science, for example, scientometrics, because these are not today library science topics, these are also research tools. If I want to understand a field, the way the fields, any of the fields are growing, what we used to say, we used to ask the research scholars that you do a literature survey and come up with your observations, open problems, show the trend. If I now ask any research scholar sitting here, if I ask to do this, say, do this for, say, generative AI, what is the open problem in generative AI? You will cry. Because you have possibly lakhs of papers, okay? And analyzing the lakhs of paper, what is the state of the art, based on that, what is the open space, it's not humanly possible. Please try to understand this. These are also important for our faculty as the PhD supervisors, we should also appreciate this fact. Okay? So now we have to use this bibliometric, all these tools. Now these tools with LLM, you can really fake, if you build up that analytics can give much more foundational approach to new science development. And this is something extremely important for us to understand and get into it. So if you see, there are very interesting work which is happening in scientometrics. If you see, all of these AI and scientometrics can give prediction of research impact, can give citation analysis, okay. All of these that we talk about today, all of these can be done through automated AI driven means where LLM can possibly play a role. Okay. You think of LLM based on IEEE collections. Then webometrics, because I shall talk about three parameters which have come in. One is scientometrics. This is webometrics, the web impact analysis, web content analysis, social media analysis, web link analysis, because today's research also goes into social media. Okay? And what is the impact on social media? That also would come back an implication on your citations, on your impact, research impact. And then classical bibliometrics. See, important is co-authorship analysis, which actually looks at what are the groups, what are the alliances growing up. Can you be part of that alliance? If you are part of the alliance, then lots of things can be shared. You are not working in isolation, but in a group. Now, these insights now was not easy for us to get when we did research. And today we should not ask our students to find that out on their own, but use tools. Look at this LLM pipeline. This is a pipeline for enterprise level document analysis. I'm not, so here the key point comes up is retrieval augmented generation. So that means I'm doing a targeted LLM. I shall not explain RAG because RAG is a very well known technique. Targeted generation, subset of LLM. So if I want to do a IEEE, builds up a LLM around IEEE, but then I can identify papers in my area and created a RAG, and also if I have a knowledge graph, use can knowledge graph for that purpose to understand. So if you see, this gives me the whole pathway that I have a vector database. Vector database may actually characterize my domain in terms of vector queries. And starting from that, I can actually build up the complete LLM based pipeline for enterprise document analysis. This can be done for commercial applications. This can be done for research applications. So I don't have time to go through in details. I'm just touching upon it because instruction prompting for structured output generation, then I can do instruction prompting, and based on prompting, I can use improve accuracy and go through fewer iterations, reduce the number of attempts needed to achieve the desired outcome as we go through, as we do our in-context learning. So therefore, if in a research lab, you build up this culture, the first research scholar has to put in more effort, but second research scholar would have much more straightforward result because in context learning, it has learned to respond to prompts much better, prompt-based learning. So a research group can also build up its own strength doing this kind of document repositories, virtual document repositories, and analysis and enterprise pipelines. Then chain of thought prompting, I think this all of us have know about it. But if you see this chain of thought prompting, today, if this is the way I train it, I can actually get a problem solving templates being generated on the basis of what has been done in the past. In fact, this is how maths was trained. See, initially when LLMs came, it was failing in maths. So chain of thought prompting was used for, so prompting, learning prompting, doing research on prompting for research. So I'm talking about prompting, learning prompting for research. The researching on prompting for research is actually a very interesting area to explore. And this is an example that that work was done actually. It's actually work of my wife, but I just wanted to show because it's very well connected with this, what I'm talking about, is recipe in the website, and it's a pure computer science problem. Okay? So there are many recipes in the website, and if you want to really do an analytics of recipe, okay? So now you actually go through these LLMs, template prompt to extract ingredients, measures, quantities, Indian names, And in fact, lots of nutritionists are interested in it. If you see, there are so many apps which are actually doing a food recommendations. Fine. Now, this is a market. Now, if somebody wants to generate things on a regular basis, he has to have a knowledge source. And this is an example that if you want to do a play on Indian cooking to make it more healthy, how can you use LLM? Okay, it's a problem of two different domains coming together and interacting. So you can get these ingredients, measures, quantities, and if you see now, this whole thing comes up in a structured form. It's a database, and based on that, it can be a actually recipe, but it was originally a web story about food, food blog. From food blog, you transform it to a kind of a structured thing. So from website to database, and then you can build a food knowledge graph for India. And it's absolutely, if you see the diversity which is there, we don't know about our food habits. We do not know what are the different kinds of grains we use, the diversity of grains, the essentiality of diversity of conservation of those grains. So I'm just connecting what is that this space actually spans across knowledge domain. And that's exactly the power of document analytics. So full knowledge graph and multiple sources. See, therefore, from LLM, using web, you generate knowledge graph. And then on the knowledge graph, you can run your query engine and you can provide those inputs to the users. So food composition, knowledge base, everything you can happen. I'm not going into it. So eat to eat or not to eat. So you can actually get all of this data, and based on that you can decide whether to eat something or not to eat something, and all of these. So all dangers and all these things can come up. This is not experimentally done. What I'm trying to say is that no experiment has been done. It based on data which is available, and from there is a authentic sources which are claimed authentic sources, cross-verified as authentic sources. So now if you look into it, therefore now if you see now as LLM as a component, and if I have LLM as a combination of LLMs, because each of the LLMs doesn't give identical answers. So when we used to talk about expert of expert, multiple expert systems, think in terms of LLMs as tools for this kind of information aggregation. So if you see you can do that, is it maybe personalized health, mental health, actionable intelligence, and therefore you can exploit food websites, social media, legal documents, sustainability news, and you can do that through number of different LLMs, deals with multilingual content, and then generate this. So this is not automatic graph. This is a structured way of solving problems, creating layers on top of the resources that you have. And that opens up, this is just one example, that opens up in a variety of domains, because your internet is a huge knowledge source. How do you exploit that in more effective way? So and these obviously there will be hallucinations over there. So now how do you deal with hallucinations? That fine-tuning, chain of thought prompting, retrieval, augmented generation, and validation against factual databases, human annotated data, and human evaluation. So therefore, I use an ensemble of LLMs, aggregate, then I do paraphrase prompts, compare answers, and validate, cross-examine over multiple answers and validate. This is actually to check whether, with expectation that all of the LLMs are not hallucinating at the same point of time. Okay, so you can use this is exactly the same thing where you used to use multiple experts to come to an answer. Okay, so similar kind of a modular approach with the multiple LLMs we can do, and therefore we have ensemble of LLMs, respond feedback, and if you see here, you can also have this reinforcement learning, which is already if you see today, it's RLHF is already there. Now, what I'm trying to talk about is we are trying on that using RLHF on the basis of multiple LLM feedback, not a single LLM feedback. Because I may not know what is the correct answer. If I know correct answer, it's fine. But on the basis of that, if there is an inconsistency, now generate a reinforcement signal on the basis of inconsistency and not correct or wrong straight away. So these are obviously, we know, but this is an open problems and this is what we need to look at, and therefore how do you use, this is where the current use of LLMs are. So what we are talking about is how to use this this is a kind of decision making system. How do I construct a decision making system using LLM as a component? So let's say, let's look at an example as agricultural policy. I think I was waiting for you to come. Okay. So if you say that agricultural policy in India, how can I form a critic of agricultural policy using all the documents and using LLM and these kind of tools to look at it? Policy making needs data-driven answers to various questions. Some of these are how climate change affect crop nutrition over the years, how is crop nutrition affecting public nutrition, how is public nutrition affecting public health. These are core policy level questions which are linked to the agriculture and what interventions should really happen in agriculture. And in fact, I picked up this example keeping you in mind. So I was just waiting for you to come. So, so if you look into this, now this is a very interesting problem that this is cross-modal, cross-domain, dynamically changing and data is spread across disparate data sources. That's why this is a very challenging issue in terms of policy making. So now, therefore, if you now look into it, everything put together, can I create an agentic system to take decisions with minimal human supervision by analyzing data, set goals and take actions to solve them. Okay? And so agents are designed for different types of tasks, multimodal data analysis, knowledge discovery, causal reasoning agents, because I have to have causal reasoning. Because right now, the causal reasoning element is missing in the LLM altogether. So I need to bring in the causal reasoning as a layer on top of that, because causal reasoning can be domain specific causal reasoning. LLMs are not domain specific in general. And so therefore, I can have these kind of a model to work on. Okay? Say I have databases, domain specific repositories of content, world knowledge, existing LLMs, and then I can do an information analysis agents, information curation with source attribution. Then in fact cross domain links, this is knowledge discovery and causal reasoning and decision support, which goes through prescriptive analytics platforms, generate plans, reason with counterfactuals and simulate future scenarios. So we don't do, when we do planning, we do imagination. The policy making is actually the biggest problem of our policy making is this. But if we can use a causal reasoning and do counterfactual based simulations, we can actually construct various scenarios with these generative AI formulations, using this LLM based knowledge as a basic input. Okay? And this is actually can have a huge implication. In fact, we have tried a simple example. I'm giving a framework. We tried a simple example. It was, we were looking at transportation in the city of, heritage part of the city of Jodhpur. Because transportation pollution is impacting the heritage buildings. Right? Now, the problem is, if I want to, my constraints are what? I have to preserve the heritage building, but I cannot impact tourism. Tourists should come to those places. So given these constraints, can I create a graph network and augment a generative model based on graph network to show how the alternate traffic planning can come up? Okay? Which would say, for example, if I'm using some roads should get converted to walkable zone, some roads should become one way, somewhere the traffic should be controlled. So it's a multi-constraint problem. And I can represent the constraints as a graph neural network, and based on that try to generate solution, and those solutions actually I feed in to a kind of a generative model to create scenarios. Okay, the scenarios are actually simulations, and see the simulations to actually validate what we are getting is good enough or not. We did it a small, very small amount of data collected, but this is the kind of an approach if you see today with your, so therefore why I am telling is because these data can give that background information, and based on that I can do this counterfactual based simulations. This is a causal simulation. That is what I want 4 o'clock in the evening to 5 to 6 a walkable zone for heritage buildings. Okay, and that is the counterfactual. That given this current situation, what if this would happen? And there can be many counterfactuals. I can actually look at counterfactual distributions to come up with most likely plan to succeed. And this is the basic principle of today's causal reasoning, causal modeling. If you see structural causal model that I have not referred to, what I am referring to is use LLMs which are not causal. LLMs are essentially associative probabilistic mapping. Autoregressive modeling is what? Associative mapping. And to that add a causal layer which is a problem specific causal layer. Okay, so that actually enables you to deal with the whole space of document driven knowledge to an actionable entity. That is, from document generate an actionable insight. So if you see, look at from this agriculture point of view, all of these scenarios to be looked at, because these channels of information are not just the government channels, and possibly the most maybe one of the most noisy channels are purely government channels. Okay, so if you want to use a public channels, government channels, and all of this together to come to a model and simulate and project, this today's technology provides you that option. And that's a document analytics actually, because these are all documents. These documents you need to actually interpret, analyze, and come to decision making. So therefore, if you see now, the outcome wise, what we are talking about is, can I do something like this? News, agricultural policy documents, food and dietary data, scientific publications. I use LLMs, RAG, KB, and all of these agentic models that we talk about putting together. Can I create a dashboard which talks about all of this together? It is not something which is impossible. Today, given the data, you can define a domain, you can define a state, and actually you can use all of these things to come up with not a human planned systems, but a machine planned system which may be objective, and maybe may hallucinate. That's why I'm bringing in the causality, at least causally valid system. And these are some of the things, this what we are talking about, this last part is an ongoing work, but we are trying to do that something as a limited space, but this is viable and feasible. And if you look at agriculture, a particular domain of agriculture, if you want to look at, say, a crop cultivation and look into the whole ecosystem of that, because today we try to look at disease in isolation, fertilizer in isolation, but if you look at completely ecosystem, environment, market, demand, okay, and financial condition, financial supply, and work out a strategy, how to synthesize that strategy using AI as a tool. And I think that's possibly the biggest possibility of AI for social good. So, in fact, people have talked about doc AI in designing of smart cities. If you see that how the urban environment, because there are lots of documentations, lots of reports which has come in. Okay, now how do you use them? In many cases, we we look at and we find there are research proposals being given doing the same thing, but they say that that is data in the document, so I don't have structured data to analyze. Statistical analysis, I should go and do a field survey. But the point is, if I can interpret that data, I need not do the field survey. This is an open area which is turning out to be very important. In fact, if you see, even IGDAR also, there have been lots of discussions on old documents, understanding culture, have a better insight into the culture. I've talked about more policy, I've not touched upon this at all, I won't get into it. But I'm just indicating it, people who are interested in not maybe agriculture or medical domain, but say on culture, there are so many historical documents which are available, the documentations which are available and which are not on internet. LLM partially looks at it, which have been recorded and documented, particularly in terms of a group of researchers who have written in English, but there are huge amount of this documentation in native languages. How you combine the two things together to get a better cultural insight. And it's, see, the volume, the problem is in all of these cases, the volume is a challenge. And because of the volume, actually you get an individualized viewpoints. Can you cross that barrier? Today these tools enable you to cross that barrier. In fact, digital humanities is a discipline which is emerging using of all of these tools and techniques in the space of humanities to look at these problems. So it's a cross boundary. Okay? So computer science to say agriculture, computer science to humanities, that whole cross-boundary travelogue you can compose if you look at document analytics or doc AI as an area to explore. This finishes my talk. These are some open issues. You can think about it. Thank you. If there are time, I shall be very happy to answer questions.
Yeah. So, thank you for a really stimulating talk. Right. Questions means like there are plenty of questions which should be there, but any specific directed questions? Yeah. Yeah. Please, Professor Vinith. Yeah.
So thanks for that beautiful talk. You have actually given problems for the next 10 or 20 years probably. But I have a few doubts in my mind which I would like to clarify. So and basically it is about the multi-model framework you were talking about. So I work in the area of visual language modeling. So one of the problems I found there is, for example, given an image where an image of a building is there. There are around 60 floors there. So the current image understanding as well as caption generation, it will actually tell what kind of building is it. But if I ask how many floors are there, this would probably be a difficult problem. And I don't think it's the causal reasoning part or any of those which could actually justify such things.
Shall I take that question first? Yeah. Before you go to the next part. See, the point is, that's exactly why I'm talking about that. This is precisely the reason why I was talking about using multimodal data. See, because the number of floors you cannot get from the image, fine? But you have a news item which can talk about that number of floors. Okay? Or there can be a report, a municipal report about the number of floors. So if you want to really use any practical application, it cannot be just a multimodal LLM to answer your questions, but you got to have a multiple nature of the data to be combined. If you see what I have talked about is using LLM or multimodal LLMs as components, add on your knowledge, add on the other documents, combine the things together and generate the answer. So if you say, if I have the data about that image, so image basically would have also the data related to the location. The location wise, there will be maybe a municipal records if it's accessible, or maybe data on the internet. If you see all cities, major cities, the data is on the internet. Okay, so now if I scrape internet in that exhaustively, which LLMs are claiming to be able to do, and based on the query and cross-query verification, can I generate this kind of insights?
So now a small query attached to that is, this is always there in my mind, because earlier I tried to do research and reasoning, and then I went into machine learning. So when given such an image or a document which has both language as well as image, do you first try to reason or learn about the language
So
part? I mean, this is always a
So
confusion.
what I'm trying to talk about is that what we have done, actually try to separate out the components. Okay, then try to discover the relationship, and then comes a reasoning. Okay, because I cannot see, if you see that, see where the reasoning in recognition comes. See, typically if you use a ML based recognition or even that classifiers, it's based on a distribution. If you say ImageNet, take just ImageNet. ImageNet can do recognition, object recognition, possibly the best tool that we have. But if you change the context of an object, it cannot recognize. Say a dog swimming, it will not recognize as a dog. Because what it has learned, dog, is that associations of the dog and environment, and all these images, over that, it has learned and generalized the distribution. The example that you are giving is not in the distribution. Okay, out of distribution. So that out of distribution, all of these classifiers will fail. If you have to deal with out of distribution, you have to build a causal model of recognition. So if you have built a causal model of recognition, you can go through counterfactuals. Okay, and going through counterfactuals, you can argue that because of this reason, this is a dog. Okay, so this is the causal part. Whatever we are doing today and what LLM is giving us, actually these associations, and huge associations. Okay, and ability to synthesize things because of these associations. Okay, and why does it do this kind of hallucination? If I ask, say for example, that who is Shantanu Chaudhary, LLM can tell that he is director of IIT Delhi, because I work in IIT Delhi, I was director of some IIT. Okay, so it will be another association. So that's a clear-cut case of hallucination. So this is the problem of LLM. Now I need to bring in the causality, that is causality in terms of, that is, if this is, see, just look at A implies B. Given A, it is B. But given B, I cannot do A. If I have to conclude A, then I have to do this causal reasoning, which actually go through counterfactuals. What if? And based on what if exhausting what if, I would really come to the conclusion, what is the most likely cause for B? That's a causal. Now that reasoning is actually much more structured and not just associations. LLM has associations, so it's building third association. And that's precisely the reason why it hallucinates. Now since I've done huge amount of associations, number of refinement of those associations, so hallucinations are gradually coming down. And that's why even if you see that all of these reinforcement learning is built in, what we suggested here is that reinforcement learning on based on multiple elements.
Thank you, sir.
Yeah, Chakrut. Yeah, I have two things. One is something about machine unlearning in the context of document analytics. The second is about mis, dis, and mal, and such kinds of information that we can analyze through the documents. So I would like to hear some comments on that.
I think the first one is, you talked about, see, let me answer the second one and you come back to the first one. See, the problem is that malinformation propagation That is precisely the reason what we were trying to talk about is multiple LLMs. Because all LLMs may not really look into the same source of data, may not build the similar associations. But if I infiltrate my web with lots of malinformation, if I use that web as a source of data, I cannot escape through any of these means malinformation. Now, if I have a cross, that means the point is that if you see, I have also shown that it's not LLM. LLM is a component. I am also bringing in other documents, evidences, surveys into the picture. That's the only way to actually counter malinformation which is there on the internet. But if it is there, if I use only with LLMs, it's extremely difficult. You can only increase your chance of filtering it, saying that multiple LLMs may not get into the same source. Okay, the first part of the question was? Machine unlearning is, yeah, so the point is that, see, so I'm not talking about machine unlearning, what we are talking about is drifts. Okay, because changing the documents means there is a distribution drift. If there is a distribution drift, these ML systems will definitely fail. The question is, today do you have any system to deal with that? Say for example, today, look at that edge intelligence IoT devices. And when you build a classifier on the IoT devices, what happens? Temperature, the moment temperature changes, the sensor sensitivity changes. If you do not compensate for that, it will generate completely wrong signals. So therefore, you have to compensate for it. Now, there are also temporal data. So when you are having a temporal data and you are doing a prediction on a temporal stream, you will find today there has been lots of algorithms which has come up which actually finds out that when you find the error between the prediction and what you observe, see, you have predicted something. So it's a sequence of data coming, you have predicted the next sample, and when the next sample comes, you look at the error. Based on the error, you actually change the classifier. And in fact, you actually make it into this is a kind of supervised learning, and make it into a supervised and reinforcement learning combination. So use, say, many cases people are using multiple classifiers and mapping that problem to multi-armed bandit problem. Okay? So how the multi-arm changes with the drift. So these are all techniques for handling the drift. Drift is a very major problem that you can't do anything with. No, 10 to 10 years. Actually, next 5 to 6 years, I think lots of problems will come out of this.
So, then these things have some place in the...
Absolutely. In fact, I tried to touch upon, I talked about some of these things also.
Okay, so thank you very much, all the clarifications, and we bring a close to this session.
So now we'll have a very quick break. Okay, so probably let's take only 10 minutes. Okay, so 10:45 we'll start.
Son, is entitled MLN Greenwich supporting complex data analysis including visualization, and this paper is a collaborative work between University of Texas at Arlington and University of North Texas, and it will be presented by Professor Chakravarti Sharma, who was yesterday also one of our panel member. So over to Professor Sharma. So we have 25 minutes for presentation and 5 minutes for question and answering.
25 minutes.
Yes, sir.
Okay. I think that should be enough. Okay, good morning everyone. Thanks for attending this session. So don't get uh, worried about the number of people on this paper. So this is a dashboard development architecture that we have been doing, and most of this work has been done by undergraduates. So the first three people, Amey and Viraj, are all undergraduates. Fariba is a PhD student, Ali Khan is a PhD student, he has been. So the basic idea is that we wanted to develop a easy to use dashboard for complex data analysis. I'll go a little bit, and we call it, this is because it's based on multi-layer networks, we call it MLN GWIZ. So I will go through, what are we developing and why, our motivation for developing this one, objectives, architecture, little bit of, how we do modularity, extensibility, end-to-end lifecycle support, and hopefully, if the internet is working well, I will do a demo of the dashboard. Okay. So, what are we developing? An interactive, easy-to-use web-based dashboard. And as far as we know, to the best of our knowledge, there is no real dashboard or web support for doing a end-to-end big data or complex data analysis, so that's what we want to do. We have chosen the graphs and multi-layer networks because that's what we are doing research on. So this whole dashboard is based upon our underlying research, and the goal is to support a complete life cycle. So the objectives are, we want to start from the raw data, CSV files or TSV files, model data into graphs and MLNs using extended ER++ approach. We have some algorithms developed for that. We also want to be able to generate graphs and MLNs, and then we should be able to specify analysis objectives in English, translate them to computing expressions using NLP if we can, and their efficient computation and drill down. Hopefully, everything is not present as of today, but we will keep adding it. Our larger goal is to make this a portal so that you can do that. So here is a sort of a view of our life cycle. So we want to be able to start with, I don't know which one to focus on. On the left-hand side, we want to be able to use structured data and other kinds of data at a later stage. So we do what is called content extraction to do that, canonical representation, but mainly once we have the base model, we use the ER approach. We use the ER approach to generate various kinds of graphs, whether it's simple attributed graphs, multi-layer networks, or relations, weighted and unweighted graphs. And then from the objectives, we want to apply this to generate analysis expressions, compute them, and then do the drill down and display them in some way. So this is the whole life cycle that we would like to support as much as we can. So the overview is, this paper focuses on architecture, mainly extensibility of modules to extend layer generation, analysis, and visualization. So right now we have 3 separate modules, one for generating graphs from the raw data, one for specifying analysis objectives, expressions, and how to compute them, and finally the visualization. It is modular because we want multiple groups, concurrent development groups, not user groups, to use to develop this system with different skill sets. I'll come to the tech stack. We have slightly different technologies that we use, and we want to be able to support multiple visualization alternatives. I believe that visualization is very important. Without visualization, it becomes very difficult to understand the results of any large-scale data analysis. And what visualization can provide in an easy way, it's very difficult to figure out. And we also want to support multiple concurrent users, and optimize the system to the extent possible. So current features of the dashboard, you can do registration, multiple users can create accounts, currently log in, maintain their independent workspace. Then we have a bunch of data sets, that publicly available data sets that we have loaded. UK accident data set, IMDb, you may be familiar with that movie database. I'm sure many people are familiar with DBLP, airlines database, and so on. So right now we don't support user uploads for fear of viruses and everything, but we are working on that. So we'll allow uploading of user data sets, because the users want to bring their data set and then model it and then analyze it and then see what it is. So that is the end aim. So we have, as we said, several modules, MLN generation. Currently we use a configuration file to specify that. Eventually the configuration file will be generated from an interactive GUI interface, so that will come later. Similarly for analysis and for visualization. So briefly, so what is the research background behind it, and why this is important? There are different types of graphs we are familiar with, and today graphs are used for modeling lot of different data sets, especially data sets of different entity types and different relationships. So there are simple graphs, there are attributed graphs, which are slightly different from simple graphs, and then we also use what we call multi-layer networks, which are a third kind, and we seem to focus on this one because the representation is, in fact, this attributed graph can be mapped into this multi-layer network, and you can see the difference between these two. The one on the right hand side is easy to understand because it has 3 layers, and each entity type and each relationship is clearly semantically separated from each other and then easy to understand. So the challenge there is to develop algorithms that can span multi-layer networks and give accurate results. So what are multi-layer networks? So they are nothing but layers of simple networks. Each layer is a simple graph with nodes connected by edges. We call it intra-layer edges. Then you can have edges across the layers. So these are interlayer edges. These represent different forms of interaction, relationships within and across layers. So both are needed for representing different types of data. So this can model complex data sets with multiple entities. Just like I showed you here, this MLN on the right hand side has 3 different types of entities and 3 or 4 different types of relationships, which is sort of gets kind of not very clear in the attributed graph representation. So analysis of multi-view is being used for solving real world problems. This has been used in very many different domains. So here is a one slide intro to different types of multi-layer networks. So we have, for example, on the left-hand side, what we call homogeneous multi-layer networks, which means that the nodes in every layer is the same, but the relationships are different. So it's easy to understand this if you think of Facebook relationship, LinkedIn relationship, or call network, or Twitter, or whatever it is. So people are the same, but the relationships are different. So these are different graphs, but there are no interlayer connections because the nodes are the same. So that's a homogeneous MLN. Here is an example of a heterogeneous MLN where node types are different in each layer. So for example, this layer captures actors as nodes. This captures directors as nodes. This captures movies as nodes. So there can be relationship within actors, co-acting and other things. Here there can be relationship between directors, but you can also have relationship that says this actor has been directed by this director, this movie has been directed by this director. So this is a heterogeneous MLN, and of course you can have a hybrid, which is a combination of these two. So now what this provides is a rich model, set of models depending upon your data set and how you want to model it. So the same data set can be modeled in multiple ways. You can create multiple types of layers, multiple types of homogeneous or heterogeneous for different kinds of analysis, and we have done that. So once you have these multi-layer networks, how do we analyze? For example, if you want to compute communities, we know how to compute communities in a graph. We know how to compute centrality measures in a graph, and we know how to compute substructures and other things. But how do we extend these algorithms to multi-layer networks? So there are essentially three different ways of doing it. And the first one on the left essentially is what is currently being used by aggregating all the layers into a single layer and applying existing algorithm. So you can aggregate the layers, collapse them in some way, or conflate them, and then say, okay, I know I have the algorithm to do it, but this can be lossy and it is difficult to drill down and visualize the results. The third approach is what we call the whole MLN approach, where you don't aggregate them, but you develop an algorithm on the entire MLN. But these algorithms tend to be a little more complex because they have to keep track of all the layers and the trees generated within the layers and help. So what we have proposed is what we call a decoupling approach, where we have an MLN, we analyze each MLN individually using an analysis function. This can be anything. It can be community, centrality, what have you. And then we have a composition function that takes the partial results from individual rail and combines them to get the result for the MLN. So the way we are verifying this algorithm is to make sure the ground truth for this is what we get here. So if what this gives is the same as what this gives, then we have accomplished the algorithm for the multi-layer network without having to aggregate them or without having to develop complex algorithm, and this has worked very well, very accurately for large enough. So we have developed maybe around 15, 20 different types of algorithms, and we are still continuing to do so. So this is the approach we are using, and we are incorporating in the dashboard, but we can also do this very easily because this one is easier, because you can just have to combine the layers and then apply the existing algorithm. There is nothing new. This one, you need very specific new algorithms for that. So the big data analysis problem, graphs and multi-layer networks support modeling analysis of complex data types, so availability of numerous algorithms. So how to make complex data analysis easy and user-friendly. So here is the life cycle that we want to use. This is very similar to the one I showed you earlier. So you start with what we call application requirements, which is a combination of your data set and analysis objectives. Then you have a layer generation phase, and then you have an analysis specification phase, and then you have a computation phase, and then you have final analysis and drill down. So the MLN GWAS is considered a modular, extensible, and interactive. So here is the overall architecture of the dashboard. So this is the user client module, which is a web-based interface. Essentially, it has two components, user interaction and display. And then the backend essentially has different components for each one. So we have a layer generation module, analysis module, and visualization module. All of them use a shared data repository or a database for doing that. And then we have, registration, login. We use SQLite and other things. So this is the overall architecture. As you can see, the separation of these modules means that each can be developed independently by different groups of people, because we use different stacks for them. And also different skill sets are needed. And we use some optimization by using, hash tables, and we materialize partially computed results from the previous user or expressions, and then we don't recompute anything, especially computing the visualization is very expensive depending upon the type of visualization you want. So if it has already been rendered, some visualization has been rendered, there's no point in recomputing. So we do all that, we store and materialize and reuse it. So the tech stack used is the following. For the website, we use the Nginx web server on a Linux machine. The client modules use Flask, HTML, and CSS. The database use SQLite 3 for user information verification and session management, and the backend is written mainly in Python, but the algorithms for various computations are not ours. They are in C++, some of them are in Java, so we should be able to invoke whatever algorithm is available in whatever language, and we do that. So here is just, I'll show you a couple of them and not go into the details. So here is the multi-layer generation module. From the client, you get a config file. I'll show you an example of that called gen, and then is layer present? So we check whether this layer has already been created by the user. If so, you are done. If not, you read the required files and apply various metrics. So we support about 10, 11 similarity metrics that can be used for creating your graphs. And these metrics, more metrics can be added into the system in a modular fashion, and then we create it, we store it, and that's what it is. Similarly for analysis, so I will not go into the details of that. So let me show, so this is a snapshot taken from the system. So briefly, this is the interface you see. This is, by the way, an NSF funded project, but it was also a collaboration with University of North Texas and Penn State. So this is what you see. So on the left-hand side, you will see your data and folders and other things. And then these tabs will become active if you pick a file and appropriate action can be performed. So you can display files, you can visualize, you can log out, you can do all those. So here is just a selected file content. Here are some drill downs that have been shown. So here is a more detailed analysis of one of the data sets. I will go through this and hopefully I'll be able to show some of this in the demo as well. So the starting point, as I said, is a raw data set. So this is a UK accident data set for different years. This has about 28 parameters, weather condition, light condition, whether it is snowing, whether it's raining, lat long, and what kind of accident it was, whether there was a calamity, whether it was not, then nobody died. So there are different things, and that is the raw data. From that data, you can generate whatever layers you want. So suppose, say, for example, we want to analyze the impact of weather conditions on accidents. So you can create a layer that is based upon weather, for example. That's whether based upon rain, whether it was raining at the time of the accident, or whether there was snow at the time of the accident, or whether it was some other condition for which there was. So these layers can be created individually and can be analyzed. Then you can also analyze, what are the most common accident-prone areas across the weather conditions by doing an aggregate analysis. Why is this important? It is important because if they want to improve or if they have limited amount of dollars to spend, they need to know what is the priority, which accident-prone regions they should consider, and which ones are not a top priority. So those kind of information can be obtained from this one. So from this, for this one, you create a configuration file to generate layers. So configuration file, this is just a sample layer. This uses the Haversine similarity metric, for example, with a threshold value of 10. And then once the layers are generated, now you can write analysis expression saying, okay, I want to compute the communities in this graph, and these communities will correspond to the regions that have the accidents that are happening very often or that are close together. And then you can visualize it in different ways. So this is kind of a word cloud. You can do it by using a word cloud or using a graph or using an interactive graph. And then if you drill down this interactive graph, you can, if lat-long information is there, you can drill down and go to the Google map and see exactly the place of the accident on the Google map where it is happening. So this is what I mean by drill down. So if I were to stop after the analysis, it is very difficult to understand what is happening and where it is happening. But this drill down process is very, very important. So you can even zoom into the road level as to where more accidents are happening as part of this one. So this is what we want to do. You cannot do it for all data sets depending upon what information it has and how much we can drill down. But if drill down is possible, we will do that. So with that introduction, let me see whether I can. So I think I opened the dashboard to check on the internet. So no. Okay, I don't know where it got open. Okay, here it is. Okay. So when you click on, so this link is available. What I'm showing you is the actual dashboard running at Dallas, Texas, or Arlington, Texas. And so you log in, you can create a login. So I already have a login created for that. Okay, so internet is not very fast, but fine. So this is the first screen you get. So this is supposed to be a workflow to introduce you, because we don't think today people are willing to read online documents and other things, so everything either has to be on the screen or forget about it. That is the attitude. So this briefly indicates how to use this dashboard. Once you logged in, if you are not done, then select an application from left panel, select a .gen file from the data files repository, generate layers, and select an analysis file, generate analysis layers or analyze layers and get the output, and then do the visualization. So this is the workflow for using this dashboard. So here is the dashboard. As I said, right now we have pre-populated a bunch of applications like DBLP, airlines, IMDb, and UK accident that I showed you. And let's say I go into the airlines file. This is a little bit easier to understand for people because people are. So then we have data files, analysis results, and the layers that have been generated. You can also generate the layers. So just to show you a sample of a data file, if there is one. So here is a analysis. So for this particular data set, we don't have, so we have 6 or 7 different airlines. Allegiant, American, Delta. So if you go to the Delta, we have some analysis expressions that we have already created, like analyze using the InfoMap, which is a community detection algorithm for the Delta data set. So you can look at it. So if I click on a file, only the buttons that are appropriate will come out. So let me go back. First show you some analysis result for the visualization, and then I'll go back if time permits and show. So we have created a bunch of analysis already, and they're all stored here. So this extension of the file gives some indication of what kind of analysis it is. VCOM means it's a community detection where only vertices of the communities are displayed. ECOM means it's a again a community detection where both edges and nodes are shown. So for example, if I click on American multi-level ecom, so this is the output. This is the output that is generated when we run the analysis. So this is not easy to understand. So to understand, you can go into a visualization and it will tell you what are the different visualizations that are available for this particular type of file. So depending upon the file type, it will display the appropriate. So if I want word cloud, it will display the word cloud where it shows in terms of how many communities are there. So let me expand this. So this one says total communities American multi-level layer is 80. C2 has 87 nodes, which is the biggest. C4 has 65 nodes, so many edges and densities, so on and so forth. So this is one form of visualization. I can visualize the same plane as a community drill down, which will again, so this will show me the communities that have been detected for these airlines, and these communities are nothing but cities that are around the hub, because the connectivity is very high and across them is not very high. So this seems to be a very large, you can drill down, you can see, and if I go on this one has some information, and if I click on that, it will tell me exactly which airport it is and show me the map of this Dallas Love Field Airport for Southwest Lines, and it will show me. So this is the drill down part where you can go into the level of detail that you are interested in. And the last one is a community bar chart, which will show you the community as a bar graph, saying these many, so number of edges, number of communities. Community 2 has this characteristic. So even from this you can find out which is the hub. Community 2 is the hub because it has the largest number of edges, so it's very easy to identify for that one. So let me...
Sir, it's about time, sir.
Huh?
It's about time, sir.
It's about time to stop. Can I just show one more if I can? Let me see. I'll just show the visualization and not other details. So I want to show you something about the UK accident data set that I showed you. So here are the analysis results. And then, so here, same rate, so ecom, so let me take one ecom, whatever the ecom is, visualize it using community network drill down. And this shows the places where the accidents are happening. And then if I click on any one of them, it will take me to the actual location in UK using the Google map, and it shows you exactly the lat and long value where the accident is happening. So let me stop here and take any questions you may have.
So, any questions? Okay, then I have one.
Thank you very much for the insightful presentation. I really enjoyed it. Just a question about maybe, I suppose, future work. A question maybe on future work for this tool.
I mean, our future work is we want to convert this into a full-fledged portal for big data analysis.
Yeah, I have a specific question there. So when you look at literature on multi-layer networks, there's a lot of work on diffusion processes, cascades, dynamical processes. Do you think that this tool could evolve to show some dynamics?
I mean, it is possible to include, but the question is the limitation on the resource, the limitation on the manpower, because this has taken us almost 2 years, mainly with undergraduate students. So that's the thing I was trying to make yesterday, that undergraduates are capable of doing very good implementation and very robust implementation. So If that is what you are hoping for, then you don't need to do a higher level degree, and there is no demand for that. So it all depends upon resources and this one. We have lots of ideas. First we want to finish the big data life cycle and then add anything else that we can.
Thank you very much.
Thank you.
So regarding this snowfall data, because normally when there is too much snowfall, then people will not come out. So traffic will obviously be reduced and accident will also be reduced.
That's not true. I mean, in countries, we had a lot of people drive. People drive. They clean the roads and drive, but still there is accident prone. So they need to worry about that, right? In a country where it has snow for 4 months or 5 months in a year, you cannot stop driving and not going out of the house.
No, but still when there is too much snowfall, I think volume of traffic will reduce. So
But
accident
even
will
when there is
obviously be reduced.
Light snowfall is more dangerous than
Yes,
heavy
that is what I want to say.
Yeah, so that can happen. So, okay, let me stop here and.
So let us thank Professor Sarma for nice presentation. So second paper is GCDR, a group-aided cross-domain recommendation framework, and it is a collaborative work between University of Delhi and NIT Warangal. And may I know who is presenting? Okay, Adamya Syam is presenting this paper from University of Delhi. Okay. It's for presentation and 5 minutes for question answering.
Good morning, everyone. My name is Adamya Syam. I am a research scholar at University of Delhi, and I am here to present our work titled GCDR, a group-aided cross-domain recommendation framework. So this is the outline of our presentation. First of all, as we all know, we have a vast amount of data available online, and it is quite tedious job to manually get personalized suggestions from them. So recommender systems are information filtering systems that enhance the user experience by providing personalized suggestions based on the user behavior and preferences among a vast amount of data. These data sources can be past purchases, search history, impressions, ratings or reviews. And few of the key applications of recommender systems are in e-commerce like Amazon or Flipkart, or in the streaming services like Netflix, Hotstar, or in news article recommendations. So one of the common and effective approach for recommendation models is collaborative filtering, where we filter the items based on the collective user preferences and behaviors. And we predict the future interaction based on historical patterns of the user, as well as we leverage the collective wisdom of similar users. One of the major problems with collaborative filtering techniques is in scenarios where we have data sparsity or cold start problem. Cold start refers to where a system, where a user is completely new to the system and we do not have any previous history about that user. So to tackle these two problems, the idea of cross-domain recommendations was introduced, which transfers knowledge from a source domain that for which we have a rich user interaction data to a target domain where we want to improve the recommendations, but we have very limited data. So by doing so, it tackles the cold start problem and helps the new users or items in the domain by leveraging data from another domain where the information for that users exists. Few of the common applications are like there is a user X which has interacted with movies but not with books, and we want to recommend some books to that user. So in that case, we can use the movie preferences of that user to recommend books. Now, one of the common approaches to achieve cross-domain recommendations is using the overlap information. There might be some overlapping users or items across domains of which we can use to map the knowledge from source to target domain. These are few of the existing works that utilize the overlapping information to map the knowledge, but one of the major limitation is reliance over the overlap information. The sole focus on them restricts the amount of transferable knowledge as they are often limited in size. In our work, we propose a novel framework that incorporates group information along with the overlap information to enhance the cross-domain recommendation performance. This framework can be integrated with existing CDR methods that rely on the overlapping information and thus can enhance the recommendation accuracy and relevance of those models. And this framework also underscores the significance of incorporating group information to address the issue of sparse overlap data to some extent. In this framework, we have used SSCDR model as the base model and have enhanced its accuracy. So we can divide the whole methodology in 3 subtasks. First of which is learning of the embeddings. So given a source domain or a target domain, we have user interaction data where a user, if has interacted with an item, we have given it 1, otherwise 0. So first of all, we learn the latent embedding for both user and items in both domains separately. To do so, we have utilized this loss function where we are minimizing the loss such that the distance between the user and its interacted item is less than the distance between the user and its non-interacted items, at least by a margin of m. So once we have learned the embeddings for users and items in both domains, by doing so, we form the groups so we have utilized the overlapping users or items to act as cluster centroids, as their embeddings represent the shared attributes between the 2 domains. And it also helps us identify users in case of overlapping users or items in case of overlapping items with similar preferences across the domains. And let me show you an example. Suppose we have learned these user embeddings in the source domain and we want to now form the groups. So let's say we have U2 and U5 as the overlapping users across the domain. We take them as the cluster centroid and calculate the Euclidean distance between each of the non-overlapping users with the overlapping users. Once we have done so, we will get the clusters on the basis of the distance. So here, like U2 and U3 are closer to each other, so they are in same cluster, and similarly U1, U4 and U5 in the another cluster. Now, once we have got the clusters, we can calculate the group embedding by taking the average of all the embeddings of the group members for that group. Now, once the group is formed, the mapping part is done. We have considered the semi-supervised mapping as proposed in the base model. So, in it, they had utilized supervised part by utilizing the overlap information. In this work, we have utilized overlap as well as group information in the supervised part, as we have knowledge about overlapping users or items and the group information in both domains. So we assume that like the overlapping users, the group embeddings in the target domain will follow the same pattern or behavior as shown in the source domain. So then we have mapped the source embedding of the overlapping users to the target domain, and we have tried to minimize the distance between the source embedding and the corresponding target embedding of that user, and similarly for the groups. So here I is the we are doing the mapping for the overlapping users. Now for the unsupervised part, as we have in the supervised part, we are only considering the overlapping data. So it might be like it may give us some problem as it is over relying on the overlapping entity. So we have also transferred the source domain items to the target domain so that we can learn the true preferences of the users in the with the help of the source domain interactions. And for that we have again used that once we have mapped the items from source domain to the target domain, the distance between the target user and the source items should be less if it has interacted with it, and should be more for the non-interacted items. So this is the whole loss function where we have used a control parameter lambda over the unsupervised loss, and once the mapping is done, we provide the cross-domain recommendations by computing the Euclidean distance between the target user and all the items available in the target domain, and the items that are we provide the top k items that are closer to the target user as the recommendations. So in our for evaluating our framework, we consider two scenarios. One is on Duban book to Duban music, where we have overlapping users, and movie lens 1 million dataset to movie lens 100K, where we have overlapping items. We have filtered out users with less than 20 interactions, and we have used a 70-20-10 train test validation spread. We considered these 4 evaluation metrics and have compared our method with these 5 baseline methods. So these are the results in terms of MRR and NDCZ, and we found that our proposed framework outperforms all the other baselines in scenario 1 as well as scenario 2, and similarly for hit ratio and precision we got better results. So this novel framework that can be integrated with most of the existing CDR methods and utilizes the group information. The significant performance improvements validate that GCDR effectively enhances the mapping process by jointly exploiting the overlapping entities and group information. Also, we found that the lambda parameter, the control parameter for the unsupervised part, has a low value for our framework as compared to the SSCDR base model, and it showcased that the group information is helping in the supervised part and giving us better results. So for the future, we can try for hierarchical clustering and sampling based approaches for the group formation, which could significantly reduce the computational complexity. Also, we have a problem with scenarios that we have no overlapping data. In such cases, we need to find other group construction methods, and this framework can be extended for multi-target recommendations and as well as explainable recommendations. That's all from my side. Thank you.
So, any questions?
So when you have, say, 2 data sets like music and the books recommendation and all, how do you know that the cross-domain recommendation will work? Like, for example, instead of books to music, maybe you want to do books to car. Now, how do you know that whether this will work or not?
Sir, we find domains that are relevant to each other. Like books to movies is a bit relevant, and for cars,
that's what I'm asking. Just by using data processing, can you say that yes, these 2 domains are relevant to each other, whether these 2 domains are not?
Sir, a bit, yes. Like we know that books are related to movies a bit. Like movies are based on few books. So in that case, like using some basic general knowledge. Yeah, movies are based on cars, but there are very specific movies, not in like.
Based on the data processing, can you get this metric?
A bit, yes, sir.
In your experiments?
Yes, sir.
In your experiments, which domain you are used?
Sir, we have one book to music and the other one is movie lens. We have overlapping items in the second scenario. We have movies overlapping, users are not overlapping, and in the first scenario we had books to movies.
Okay. No, no. The question is, there will be significant mistakes are there. How you avoid that?
So like,
In that the recommendation here, the recommendation may not be there actually. Do you get enough training set actually?
sir, like you are saying that there is a interaction for that user in the book domain, but not in the target domain. Yes, sir. Sir, that's why we are doing the mapping now. Okay.
Any other questions?
So you have done mapping from books to movies.
Yes, sir.
What about the reverse movies to books?
So it can be done.
It can be done, but if you have done both ways, then you may have a comparison. Which one is more accurate?
Okay.
Are they are same?
Okay, sir.
Okay.
I will extend this in my course.
Any other question?
Okay, sir. Yes, sir. Okay, sir. Sure.
So let us thank Adamya for a nice presentation.
Thank you.
So third and last paper today in this session is CKELM Unified Approach to Parking Space Classification for All Weather Types. And this paper is from authors from Thapar Institute of Engineering and Technology. And may I know who is presenting? Oh, joining online. Hello.
Your voice is echoing.
You know who is presenting?
May I start?
Yes, you can start. You have 25 minutes for presentation and 5 minutes for question and answer.
Good morning, everyone. Myself, Nopri. I'm a PhD scholar at the Thapar Institute of Engineering and Technology, Patiala, and Punjab. I'm here to present my paper. The paper title is a CKELM, Unified Approach to the Parking Space Classification for all weather types. Thank you for giving me the opportunity to present my paper here. This is my outline, the brief introduction, then the proposed methodology for the parking space classification, and then the results, then the different experiments which I have conducted, and the result analysis of that experiments. After that, the conclusion and the future scope of my proposed work. Now, if I'm talking about the parking space means traditionally the parking space classification is usually done by using the sensors, which are very tiny, which have the sensors are used to detect the parking space. Then data is transferred to some center server, then process it, and the status is marked either it is a vacant or the occupied. But the parking spaces which are done, which is usually done for the only the clear weather conditions, means the spaces which are clearly the images are the which are clearly visible. And for this purpose, I have proposed a approach to detect the parking space under the some under in a foggy or the hazy conditions. And for this purpose, we're using the computer vision approaches. Till now, the work that has been done by using the sensors, they have some limitations. The limitation is like that the sensors have the very high maintenance cost. If we have some updates, then we need to update the sensor technology, and the system there are some security concerns in the sensors. To avoid this, we uses the CCTV cameras which are marked inside your parking slots, which are capturing the images. And for this purpose, for the second thing, the data set for the hazy conditions till not is there. For that purpose, we use the CCTV cameras to capture the images, and then some apply the augmentation. The images are very limited, so we apply the some augmentation technique to augment it for my purpose. So the deep learning techniques we have applied for the classification of the parking spaces for the hazy conditions and the non-hazy conditions. The If we directly apply the deep learning technique to classify the parking image which is captured in a hazy image, the performance of that model will get degraded, because the image the hazy image is like an obstacle in the case of your image processing. So we pre-process the hazy image to remove that haze effect from the image and convert it into dehashed image, and then we apply our technique. So in this paper, I have proposed a technique that works on both the weather conditions, means the clear weather conditions or the hazy weather conditions. So this is my methodology part. Firstly, what we did, we built a CNN model, deep learning model, which is based on the architecture of the AlexNet. Then the CNN, especially, they are well known for their feature extraction properties. They have the very good feature extraction properties. Means the CNN is used for feature extraction. Then for the classify purpose, we use the kernel extreme learning machine. We did with the extreme learning machine. Why we use this extreme learning machine? Because in the CNN, they have their performance, their training time is very high. When we train the CNN model on our dataset, their training time is very high. We consider the two things in our proposed approach: to reduce the training time as well as the performance of the model. Till now, the researchers only consider the performance of your model to means get the better performance. But we work for the two parameters: reduce the training time which is required for your model, and then the as well as the performance. Training time, we work on the training time by the placing the your kernel EMLM at the fully connected layer of the CNN model. In the CNN model, when the first time the model is trained, it is the loss is calculated between the training loss and the validation loss. And if the performance is not up to the mark, then we again train it. We again train it means to do the back propagation to set the gradients of your model. To avoid the backpropagation, we use the kernel ELM to place at the fully connected layer of our model. So the second my objective of my this proposed approach is firstly the data set that is not there for the hedgy conditions. So we prepare the data set for the hedgy conditions, then pre-processes to work it as like the non-hedgy weather conditions. Then we test it on the two data set that the one is the synthetic data set named as the hedgy parking data set and the well-known public data set that is a PK load which contain the images of your images in the sunny or cloudy and the rainy weather. And the different parameters we consider for the evaluating the performance of the model: precision, recall, sensitivity, accuracy, and F1 score. Then the proposed model is performances of the proposed model is compared with the various ML classifiers like the SVM, XGBoost, KNN, Random Forest, etc. And the similar model, similar existing deep learning approaches, the performance is also compared with similar existing deep learning approaches. This is in the short summary of my first data set, that is a hedgy parking data set, that images are captured under hedgy conditions. That we have considered for the total we have captured around the 752 images, that is unaugmented images. Then we apply the rotation, flipping, and scaling to uh, to augment it to augment the data set. That then we can divided this data set in the ratio of the 70 to 30. 70% the trading part contains the 70% and 30% part in the testing percent. Second data set is a PKLO data set that have the three folders: UFPR 04, 05, and the PUCPR. 04 and 05 stands for the means the building fourth floor and the fifth floor of the building capture the images under the three weather conditions: sunny, rainy, and cloudy. And we also divided this data set in the ratio of the 70 to 30. Now this is my proposed architecture diagram for my model. Firstly, what we did, the hazy data set, firstly we dehaze it by using the LDNet model, which what we did, it calculate the dehaze part of the image and calculate the difference between it and generate the dehazed image from it. Then we build the CNN model. CNN model architecture is based on the LXNet. Then to avoid the backpropagation, we replace the fully connected layer of my CNN model with the kernel ELM. Firstly, we did with the ELM. Then we try the then we change the kernels of the ELM with a different type of the kernels. Train the kernel ELM on this the extracted feature map which is generated by the CNN. Then we do the classification by the kernel ELM and check the output labels whether it is a busy or the free class. This is my result analysis purpose. Firstly, the CNN is used for the feature extractor map. The feature extractor is the first time it is trained for the 5 epochs and the feature extractor is generated. Then we pass it to kernel ELM to train on this feature extracted map and generate the performance matrix. If we did not get it the better performance, then we again train it. Between the 5 to 20 epochs, we train it and we get the better performance in between the 10 epochs. And then the different performance matrices calculated for the this proposed model. And the performance is the different experiments like we perform try with the different kernels, linear, RBF, and the Gaussian kernel. And for the performance comparison of my proposed model with the machine learning classifiers, we applied the grid approach to setting the parameters of the different machine learning classifiers. This is a confusion matrix for my hazy parking dataset and the PK load dataset. And then we try with the second experiment, that is apply the different kernels inside the extreme learning machine. Extreme learning machine have the kernel one is a simple extreme learning machine without a simple linear kernel. Then we apply the different kernel like the linear, RBF, and the polynomial. In this, the extreme learning machine consists of the 3 layers. One is the input layer, then the hidden layer, then the final output layer. There is no propagation, any back propagation in the ELM. It is very fast and having the very fast learning speed because the does not involving the back propagation. And the inverse of the matrix, that is the target output matrix inverse, is calculated by the Murray-Penrose inverse. So we calculate the accuracy and the specificity in the both the data sets. Then these are some performance metrics are calculated for both the data sets, precision recall and F1 score. Then we try with the experiment with the different machine learning classifiers like the linear regression, random forest, KNN, GNB, and XGBoost and SWIM. We tested our model to test our approach. We tested along with the CNN also and the kernel ELM also. By doing by doing this, we get that if we CNN trained for the CNN is trained for the 10 epochs, we get around the performance of the 94.65% for the Heji parking data set and the kernel ELM alone 82.56. But by the assembling of both the models, we get the better performance in the case of the CNN SVM, and for the parking log data set, we get the better performance for the UFPR05 and the PUCPR subsets. These are some performance metrics that I have plotted for all the ML classifiers. And then the performance comparison of the CKLM with respect to the CNN ML classifiers. Finally, we compare the performance of our proposed model with the existing models. For the Heji parking dataset, very limited work is done. Only one paper is there that have compared with the they have proposed two models, AODNet and AODNet plus modified MLXNet. In this case, our model also attained a better performance, that is accuracy of 97.56%. And then we compare our performance with the another data set for the parking load data set with the proposed model. And second thing, we compared with our training time of our proposed model. In the CNN, we get the training time of around the 4,728 seconds. But for the integrated model for the Heji parking dataset, it takes around the 0.13 seconds. In the same manner, we tested for the parking load dataset. For the three subsets, we measured the training time and compared it. Finally comes to my conclusion and the future scope. So this proposed model works in three stages. Firstly, if the image is not completely clear and it contains some hash, then the LDNet is applied to remove the hash and creates a dehashed image. Then the dehashed image is passed to the CNN to generate a feature map. The feature map is then passed to the kernel ELM to classify into the occupied or the free classes. Finally, if we want to in the future work, if I want to enhance the performance of this model, first basically to try the different variants of the ELM to get the better performance and reduce the computational time further. These are some references. Thank you, everyone, for listening to.
So any questions?
Are you able to hear me?
Yes, sir, I am able to hear you.
Okay, good. So how do you define the hedginess?
Hedginess means the image is not clear, like in the north weather of India, especially in the season of December and the January, the whiteness in the image is called hedginess.
That I understand, but how do you define the hedginess?
Means the boundary of your object is not clear in the image. Like if I have a car will be recognized by its lights.
That we understand that if it is not
But the like a clear screen of a white thing in the front of you.
so my question is that whether how do you define the level of hedginess?
Are we audible? No, but I don't think we are audible. Only through that we are audible.
You speak.
Voice is not audible. It's echoing.
I have typed in the chat box. Can you look at?
Please follow the chat box. You can please speak.
Yes, sir. The level of edginess means the image is not clear and visibility is very low, and it's means it is like a obstacle in the image, or even the modeling we apply directly to it. It is not able to classify it.
Napreet,
Yes, sir.
normally such things are classified in terms of visibility. You have 10 meters visibility, you have 20 meters visibility. So, have you related your model with visibility that it will work with this much visibility?
No, no, sir. We take means the you are able to find the parking space or not in the hazy weather because the
But
boundary
hazy
is
means
that.
that you have just introduced some random noise
Yes, sir.
or something else.
He means in the our model in the sense that the image is not clear. Means it is completely white. We have to remove that white part from the image so that the natural image is clear.
No, no, no. But white means that white image or image. Are you getting my question?
No, sir.
Whether you have introduced this whiteness in the image or these images are natural.
No, no, sir. The images are natural. The images are captured in a hazy weather. Means like in a foggy weather, the image which are not visible at all.
Okay, fine. Any other question? Okay, thanks, Napreet, for nice presentation.
Thank you so much, sir.
You can disconnect now.
Sure.
So, welcome to the next session where we have an invited talk by Rajiv Gupta and Rishabh Malhotra, both from Microsoft. And the talk is titled Scalable Entity Extraction Using LLMs and SLMs, Challenges and Implementation. So while the system is getting set up, let me introduce the two speakers. We have Rajiv Gupta, who is a principal researcher at Microsoft, and he works in content recommendations, information extraction, and also in the use of large language models for various applications. He is also earlier a chief architect at IQLect and a senior researcher at IBM Research before he moved on to Microsoft. And what's interesting is his education spans 3 IITs going from east to west of India. So he has his BTech from IIT Kharagpur, MTech from IIT Delhi, and PhD from IIT Bombay. The second speaker we have is Mr. Rishabh Malhotra, who is a data and application scientist at Microsoft. And he works in NLP and information retrieval. And he's also worked on several projects that involve generative models of AI. And he's got his BTech from Punjab University and his MTech from IIT Kharagpur. So I invite Rajiv Gupta to start the presentation. And looks like there's a, the technical issues have all been resolved. And I now, so Rishabh, you're going to start?
No, Rajiv is.
Rajiv, okay.
I'll just open the presentation.
Yeah. So Rajiv Gupta is going to start the presentation. Let's welcome Rajiv and Rishabh.
As I said, the title is about okay. Is it audible now? Yeah. Yeah. Okay. So we will be talking about scalable entity extraction and using large language models and the small language models for them. And we are from Microsoft, so as you can expect that these technologies are going into Microsoft product at different stages of product development. So let me start with the
one scenario here. And yeah, I mean, if you have any question, just raise your hand and let's clear the doubt in between. I mean, let's not wait at the end. So, like I said, that this is the Microsoft product. I mean, you may have known Teams, and in Teams you can go and put this query. What are important tasks for me from my email? This in the Teams there is a Copilot. Copilot sort of has access to your emails, your files, your Teams chat, and then when you put this query, like for example, for me, these are the tasks which came up. Okay. Now, how do we answer these queries? That's what we will be talking in this session. So as you can expect, like there are lots and lots of emails, and I mean more than hundreds of billions of emails are exchanged every day, and of course big part of it through Microsoft systems. So like, is it possible to run this query, how to run this query in a scalable, efficient manner, so that, yeah, I mean, whoever are the Microsoft customers or whoever are the users of the teams can put these queries. And this is just an example query. There are other queries like that. Like, for example, automated form filling. I want to send Diwali gift to the whole team, so I need addresses of the whole team. And addresses are there somewhere in my email or team chat. So I need not ask those addresses to the folks and do that. What is the seafood restaurant near my home? If this is the query, then this is the query which involves web data as well as your own data. Because when it says near my home, it needs to know what is your home address. And seafood restaurant, probably it will get from the web, and then say that, okay, these two locations are closest to each other. Or there is another query like, who knows about a particular technology in my team? Now, first of all, what is Azure data box, and who knows about it? That can be obtained by the person who have written the document on Azure data box. Okay. Plan my trip to Jaipur. This is very interesting. Suppose there is a Microsoft Office in Jaipur, and I am going there, like then, and I want to make it like work plus say pleasure trip. In that case, like I want to see that who are the people I should be meeting in Jaipur, and what are the places I want to see in Jaipur. So it's a combination of that. So all these queries we plan to support, and using, like I said, some are supported using your own data, which is like customers' data, and some are combination with the web data. Okay. So, and these, like I was talking about the scale and all, 94% of the enterprises uses cloud. So all this data is there out there, which can be processed to get the answer these queries. And like 48% of the enterprises store the classified data in the cloud. We will come to that, why we are talking about classified data, because customer data, after all, is the customer data. We as an employee or a researcher, we don't have the access to that data, right? Then what do we do for building the information extraction model like these? Then, of course, with the large language models, we have to talk about the AI. 91% of the companies are adopting AI for the same, and like number of business emails sent per day. This is 2018 number, and this is the reference here, is 120 billion. And for example, a particular typical user, enterprise user like me, receive 76 is a small number for me, but yeah, 76 email on average per day. So going through those emails and trying to say that, okay, what are my tasks for today is a tough thing. That's why we need all this automation technique where I can just go and ask the query and it should be able to give me the result. Okay, all these comes under the productivity application. How do we improve the productivity of the
enterprise user. Okay, like so that the employees should spend less time searching for and organizing information and spend more time in drawing insights and do some useful work. So that's where, like, can you share the latest version of the proposal? Now, suppose this is the query, then can we, rather than user getting the latest version of the proposal, can we automatically create the email for the user that here's the latest version of proposal, just send it, right? Or my passport number is there somewhere. Multiple times I have mentioned in my email with a different, say, flight reservation or somewhere, right? Then if another email comes that please send me your travel details or something, it should always automatically should complete this sentence. Okay, flight tickets, right? If I'm traveling to Jaipur, like I was mentioning in the last slide, it should automatically say that, okay, I'm traveling to Jaipur and this email has come because, and so it should change my calendar invite to the busy that, okay, I'll be traveling during this time and all, right? The example about Azure data box, this again, the information is available, and if I want to explain somebody what is Azure data box, or like somebody has sent me an email with the phrase Azure data box, I should be able to hover over it and get like what are the details of it, right? So all these are productivity applications, and for all these productivity applications, we need to do the information extraction from the customer's data, the email, chats, and documents as I mentioned, and that's what with the core theme of this talk. So let's see the detail of the core theme, which is the entity extraction. And like I said, my entities can be number of things, like flight information can be one entity, passport number can be another entity, address can be an entity, or more abstract entity like task. What are my tasks? So for all these, because we want to do the scalable entity extraction, we don't want to build a separate type of system for all these entities. There can be some like in the range of 30, 40 different types of entities we are extracting. And we don't want to do like for each entity we have different system and all. That's where we are saying that one aspect of scalability is the scalability from the point of, suppose we want to extract a new entity, we don't want to build a new system. Existing system or similar system should work for it. So that's where this is the ecosystem which we have. So user inputs are there, and user input goes into, but say for example, Outlook. Outlook will create an email, and those emails, what we do is we do the entity extraction, and the entity extraction output is sent to the, is some kind of structured representation of the entity, that yes, this is the task is assigned by person X, and this is task for you, and you need to complete it by tomorrow. So that's a structured representation, and then this can be used for various applications like task suggestions, knowledge base creation, calendar update, or bill payment, or whatever. So this is a typical ecosystem which we have, and we will explain in the context of this. Okay, so like this is an example. This is an email where like Jack has written to Alice an email where this is the sentence. If so, could you please share it with me, right? If this is the sentence, then we can say that probably Jack is asking for some information from Alice, and the document is also written document you mentioned about how to submit jobs to new cluster, right? So first of all, whether this email contains the task for Alice or not, that's the first question. Then what is that task? That's the second question. The task is about sharing a document about how to submit jobs to a new cluster.
and then further helping Alice that, okay, this is the document, and go another step, create an email for Alice automatically so that Alice just needs to just validate it and send it, right? So, and there can be other example, like for example, Alice is saying to Bob, I'm giving a demo to new customer on Friday, I'm thinking of slide that you presented last week, right? Or, and then Alice says that sure, please find the slides attached. Now, if we say that this is an email which Alice said to Bob and this is an email which Bob said to Alice, if we can correlate these two emails to say that the Alice has done her job, right? So all these are part of email inferencing which are related to entity extraction, or that's where I'm writing it, the intent identification. What is the intent? What user wants to do? Okay. Okay, so these are some more detail about the task entity extraction, and all these detail, there is a SIG-IR paper, and you can go and look at it. So large fraction of tasks are about information exchange, right? Whether somebody is asking some information from you, somebody is sharing some information, or somebody is requesting some action, like can you schedule a meeting for tomorrow between two of us? That's a action request. Promise an action that yes, I will send you a document by Wednesday. That's an action. And the task completion, like I said, that when if there are multiple emails, we can correlate, we can find that this task was defined, and then this task is complete. And there are other tasks like scheduling, like meeting intent and reminder, and the social interaction, and some of the examples are here. And among all these tasks, if we analyze on a avocado data set, information exchange tasks are many more than say social communication or the task management, right? So what, for example, when we want to do the entity extraction, task is one of the entity, and task can, as I said, can be of multiple types, information exchange, scheduling, or maybe a generic action, right? So this is one entity. Another entity is address extraction. Say we, like in various email UXs, you may have seen that there is a contact address book, and you can just get the person detail from there, right? And this is an address book and the entry for Mona Can, right? And we want to update that, okay, what is her mobile number, or what is her, which company she works in, and this may already be there in the email. So that's another entity extraction which we are doing. In fact, for big part of this talk, we will be considering with address as an entity. Okay. Okay. What are the challenges? As I mentioned in the beginning, that this information extraction is happening on the customer data. So privacy, of course, is the biggest challenge. I mean, in fact, that's one thing where we don't get like the kind of work which is done in academia and kind of work which we do. That's the biggest difference, in the sense that like we are not allowed to look at the data. Without looking at the data, you need to develop ML models, say for example, right? So nobody can read users' data without users' consent. Number and types of data is too large, and here not only number of emails, even the number of entities which we are extracting is the scale issue. And performance, many of these queries which I am mentioning in the beginning needs to be answered in real time or near real time. Now, whether you can sift through users lots and lots of emails and answer this query, so that requires, and further we are talking about the language model. Language model by definitions are like multiple seconds they take to return a result. Now, if you want to do multiple queries to satisfy one user need, then we have to be performant. And of course, legal, right? Where do you store the data and all, government get involved and all, right? Is the problem statement clear? And like, then we will go into detail of solution. Okay. So, as I said that from the
scalability is the biggest issue for us, considering the privacy of the data and maintaining the quality of result. So how do we balance the scalability and the quality? Like we want to have the similar pipeline for different entity types, but all entity types should be extraction with the good precision and recall. So because we need to process billions of emails, so the system has to be lightweight. We can't spend too much time on the email. We can't spend, say for example, 30 cents per email. That's not allowed. That will be too costly. And how do we minimize the number of language models called? LLMs are very costly. They involve GPUs and also, yeah. And since all entities require extraction, so otherwise you can't develop the reliability on the system. If there is some task pending for you and system doesn't come up with that task, then there is a recall gap. If there is a recall gap, then recall has to be 100%. Precision can be slightly lower. So that's what we are saying, that we require a high recall system. And of course, with the language model in there, it can be hallucination. It's possible that whenever we train the model, there was some training data and the model remembered the training data. Now, even though your email may not have the address of, say, Narendra Modi, but in the training data it was there, so it can tell you that address of the, that should not happen. All the answers should be there based on your data, right? Okay, so this is the extraction workflow we have. So as part of, like I mentioned, we take the input emails and we have a pre-filter, which is sort of, you can say, some emails we don't want to extract information, say spam emails, right? We don't want to extract information from spam emails. Some of the emails are automatically generated emails. We don't want to remove, we don't want to extract information from them, so we remove that. Then we use the language embeddings. Language embedding can be like space V embedding or Turing embedding, and those language embeddings are used to identify whether that particular email contains that entity or not. Because say for example, if the entity is task, then it should have some language like please send me the document you mentioned, right? So there is a particular construct of the sentence. So using language embedding, we can identify that yes, this email contains the task, okay? And then we use the language model to extract the task, okay? And then like I said, that the language models can do the hallucination. So just to be on the safer side, we have a post processor. So what post processor does is, whatever task or whatever entity is extracted, we want to make sure that this entity is indeed there in the user's grounding data. Okay, so that's what the post processor ensures. So this is the pipeline which we use. Now the question is, we will be concentrating mainly on this part, prompt and the extractor. How do we minimize the number of LLM call? How do we minimize the cost associated with the extraction and all, like, because LLMs are costly. Can we use the small language models? Small language models may not be that performant. How do we improve the performance? Okay. Yeah. So now Rishabh will cover the technical work associated with extraction. Yeah. Yeah. You.
Yeah. Okay. So before I get into like how extraction is done using LLM algorithms, I'll just briefly explain like how we are measuring the quality. So how do we know actually that the extraction quality is good? Now, first of all, like addressing that question. Yeah. Hello, am I audible? Yeah. Okay, so just answering the initial question that you might have, that for extractions, why are we actually going to say large language models or SLMs? why we could not do it directly using, say, a simple NER model, assign a text span, get the address out of the email. But here the problem is slightly more complex, where when we do an extraction, we don't just do a span extraction, we assign it to a particular person. So every task would be related to some person that is present in that email. There might be multiple persons present in that email, and similar for address, phone number, and all the entities that we are extracting. So the simplest approach is to probably target LLMs or SLMs like for this kind of extraction. But like evaluating a generative model's output is slightly trickier than a simple 0-1 model evaluation. So going on that one, so how do we compare the LLM SLM with say human annotations? We can simply get some like a manual intervention here, some human annotations done and compare that. However, human annotations, like as we pretty much all know, that these are very costly. Like it comes at a cost of both time as well as money. So what we are evaluating here, one could be presence-based metric. So let's say a human said that, okay, there is a phone number present in this email, and LLM also said that there is a phone number present in that email. So this could become a true positive. Where they mismatch, that's where basically false positives and false negatives come into picture. But there is a like simple issue with this one, that we are not actually comparing the values that are extracted, whether the address extracted is a correct extraction or not, or when we just compare the presence based metric, it's just a kind of a 0-1 output again. So what we want is kind of a similarity based metric, which I'll define next. So how does this similarity based metric work is that, the entities that we extract. So here I've given an example of contact info extraction. So if you see this, like we have name, first name, and address associated to that person, and then in the end we have the phone number also associated to that person. We could extend this to, multiple more entities that would be part of that single email. Now, this is a JSON format that we plan to extract using an LLM or an SLM. But when we do that, then we like represent it in a hierarchical format, like each name can be associated simply with an address. How we try to compute the similarity is that we just take the longest common subsequence of the response, of the like outputted response, and we divide it with the extracted response length plus the ground truth. So with this, basically we compare it kind of letter by letter of the longest matching common subsequence to get the similarity score. I'll explain it again, like how this is different from a presence-based metric and how correctly it can predict the response. But we threshold it at a certain value to get like say after point, if this value is greater than 0.8, then it is a common or a correct extraction. So it could happen that a human annotator might not have marked the pin code correctly for an address, but LLM might have extracted it, and vice versa. But it is still like it is an incomplete extraction, but it is complete in a certain sense that we are okay or acceptable to be in. So that's how we do it. Yeah. So this is one example I was talking about. Okay, so yeah, so if we see the first one, right, so let us assume that this is the human annotation on the left hand side, and on the right hand side we have say the LLM extraction. So if the left hand side we see that output present is there in both of the sides. So if we just compare the present based metric, then this should solve this, because we are in a real world, and like those are considered to be true positive, and our metric value that we get will come out to be pretty good. However, if we actually compare the outputs from the left and right side, so there were two contact information that were present in that email. However, this side is only one, so that's clearly a false negative. So that's why pretty much we go to the similarity based metric, where instead of just the presence based metric, we actually calculate more details on like what the extraction actually is. So moving on, just as Rajiv explained, right, this is the workflow that we had. In that we have this LLM or human ground truth, and we have a post processor for that annotation as well. And then we do the comparison for both of these and we get the metrics. So I'll now go to like how do we actually do these extractions. So first, the simplest idea that we had was to write a detailed prompt of what entity do we want and how does that entity, is that entity defined. Say for address, we'll give that, okay, address contains street, city, zip code and all those things, and we'll give a very detailed prompt. Additionally to that, if you see this prompt, like we give specific instructions like do not give anything else apart from the text extracted from the input to preserve the privacy of this, right? And when we checked GPT-4 performance, like it was extremely good when we compared it with human annotations. Like it was around 97-98% precision recall, so it was great. But there was an obvious problem with like doing all these extractions with GPT-4, and I guess you might have all guessed it. It was the cost. So we cannot send like Microsoft scale level of emails, like billions of emails per day to GPT-4. Yeah, so that was the biggest issue. Plus the cost of GPT-4 model is like actually, like related to the number of tokens that are present in the prompt. So as and when we make the prompt detailed, as and when the entities increase, the prompt becomes bigger and the cost increases further. So that was the issue. So for handling these things, like can we use smaller size models was the question. So yeah, then we started exploring like small language models. Like in the past 3 to 4 years, like more than 100 small language models have been released, and out of those, like if we compare the performance in the chart below, like Phi model was able to outperform pretty much most of the small language models, especially on the extraction based tasks. So yeah, it was reasonable enough. It was also publicly available, so it was pretty much reasonable to start with the Phi model. However, when we like compared it with LLMs, because LLMs have a lot more domain knowledge as compared to SLMs, the performance numbers looked like this. By the way, this is one entity extraction. We calculated these numbers on multiple entities, but this is on address.value similarity, and this is that similarity score that I was talking about. So 3.5 turbo and 4 mini were pretty much performing well, because this is a hard metric like as well. The performance that presence metric was even higher, like in the high 90s. So we were getting 80% F1 score with both GPT 3.5 turbo and mini model. However, when we tried directly with Phi small model, then we got around 50% F1 score, which was a significant drop. Like a 30% drop was not expected. So a thought process behind it that we can probably fine tune it, but for that we need domain specific learning. And what I mean by that is simply that we need labeled data to actually fine tune a model so that it understands what exactly address means, and that's how we proceeded. So moving on, yeah, so the initial problem that obviously we have with fine tuning is that we need data for an entity. And since entities can vary, right, so from tasks to phone numbers to addresses and whatnot, for each of these entities, public data sets are not available directly, and definitely labeled data sets are not available. So what we did, we had one simple public emails data set called the Enron emails data. So what we did, we got some heuristic filter out. So we have some Azure PII filter that we try out to get relevant emails. So they might contain some of those phone number things. We rule out some of the automated emails first, and then we wrote another prompt, which we here call the augmentation prompt. What we did using this is that we actually augmented that entity specific data to those emails. So if that particular email does not contain a phone number, then I probably augment it with a phone number. So that's what this augmentation prompt does. In addition to that, what we saw that, what LLMs do is that they try to preserve privacy as much as possible. So when they try to augment some entities, then like the phone numbers that they generate are very simple, like 1, 2, 3, 4, 5, 6, 7, 8. So we wanted some variety in this. So that's why we added something called as faker API entity samples. So if you see this, like this is a public API available that can generate some entities for you. After that, we directly use this GPT-4 model that I earlier showed. So this similar prompt that we had. So this one, because we had like very good precision recall numbers with this one, I could directly use this to at least annotate the label data set that we have. So then pretty much I have the label data. Although like Rajiv will discuss about this, that this data set does not have that much variety as we can expect. However, this is pretty much public data. We use like public libraries to generate this data, and we just use a simple prompt to annotate this. So if you can think about this, this is entirely an automated pipeline where we augment the entities, that is also automated, and we pretty much label the entities, that is also automated. The only thing that is an input from a user, that is a prompt. So this is how the like fine-tuning framework looks like. Like we had that synthetic data, we sent it to that labeling pipeline, and we have the label data set from it, and then we run the fine-tuning algorithm. The important thing with fine-tuning is that you don't need a detailed prompt, because you have the input data, you have the output label. Now it's more like a traditional ML problem where you have the input and output defined. So you can probably like compress the prompt into something like 10 tokens, extract task from the input email. That's what the prompt was for the like fine-tuned model. However, for the like off-the-shelf model, the prompt was pretty huge. So we gave the prompt with no instructions in this one, and then we got the fine-tuned model. Another thing that we have with fine-tuning is that when we fine-tune these models, since these models are pretty huge, like fine-tuning the entire model like takes a toll on the systems. So we use something called as low-ranked adaptations technique. With this, we fine-tune only some specific layers of the model, which turned out to be like around 0.5% of the total parameters. So that way we were able to fine tune it pretty quickly with an 8 GPU system. Any questions till this point? Yeah. Yeah, sure.
You have talked about large language model calls.
Correct.
They are costly, and they run on GPUs.
Yeah.
So when compared to the emissions, does the application that you are working on meaningful? Does it help anyone?
Yeah. So applications, I think Rajiv presented earlier itself. There are a lot of applications of these extractions. So like these extractions actually power the products that we have in Microsoft. So yeah.
Maybe it is, I mean, it is centered to the company, and can we make it more socially responsible?
Yeah. Like we have a pretty much section dedicated to how is it like more socially responsible, and Rajiv will pretty much cover up that, like how we preserve the privacy, how we can probably extend this to even extracting, say like this is an extraction problem is not just, I wouldn't say that's company specific, right? So say extracting important news for a person, that's not maybe a company specific problem, right?
Because
that could be
when compared to the GPU power consumption, we are going to bear the brunt, the global warming, as you know.
Yeah.
So why not make it more meaningful? rather than filling up automated forms or saving your passport number?
Yeah, I mean that's probably a question that the company could answer, but yeah, I would leave that to them. But yeah, I would probably like to elaborate on that one. Like our goal when we start an experiment, then initially we start with the best possible performance that we can get, right? And that particular thing we can get from like the larger models. But those experimentations are not expandable to like billions of emails, and we are not running it on that large of a scale. They are run on a specific set of emails only. When we are and then our goal itself is to like reduce the cogs using like lighter models, reduce the latencies and all, and that way we ourselves try to reduce the GPU consumptions. So yeah, I mean in a way we are targeting that only, but how we could maybe help in the social responsibility in this one, maybe Rajiv could elaborate on that more. Yeah.
So, I mean, some of the applications are the productivity application where we want to improve the productivity of the user, right? Now, you can say that the mobile is also a productivity application, and mobiles are leading to global warming.
Yeah.
So it's all a continuous behavior.
Correct.
I mean,
I
it's
agree.
all like, I mean, we want to make the whatever used to take, say, 1 day to, like, say, for example, a company executive will have some secretary to monitor that what are the pending tasks for that executive. Now, instead of that, we are doing it automatically so that you can reduce the manual labor from that those things. So
Yes, yes, we'll come to that.
We make use of these resources, GPUs, LLMs. Can we combine these high computational facilities for something useful like that?
oh, that is already
Bigger problems,
of course.
not
This
petty.
is, yeah. But of course, I'm not that great to solve all the
Maybe
problems in the
because
modern
you have the computational facilities with you, maybe you can collaborate with universities, humanities
Yeah,
departments.
yeah.
That is true, and
Yeah.
that's we are collaborating with universities for other problems. Like
Yeah.
for example, I'll give you an example. I mean, during COVID time, I mean there was multiple types of tests were available, right? RT-PCR test, and the other one was the what was it called? I'm forgetting. But anyway, the RT-PCR test was low precision test, whereas the other test was high precision. But RT-PCR test was very I mean very fast. You can get the result in few hours. So the effect of RT-PCR test, or especially if the person is positive, is very high in the sense that if you can find the positive person quickly, that is very good, right? So here technology was used to identify that which, like how we should allocate the resources for RT-PCR test versus the more DNA-based test. So, I mean, those kind of collaboration are there. But yeah, in this talk, we are not talking about those collaboration. Here we are
Correct.
talking about the productivity applications, how we can make employees or the users more productive.
But
Thank you.
that's
Thank you.
definitely a good suggestion. Probably, yeah, we can talk about that. So this is how the learning rate schedule looks like. So we used a cosine learning rate schedule. So it's kind of a decreasing learning rate as we move forward. And this is the cross entropy loss graph. So if we see when we fine tuned, the model was gaining insights on what those entities are, and the loss started reducing. And this is how like the result looks like, the initial result on the fine tuned model. So if we see, like, we were able to match the performance of pretty much match or like get very close to the performance of like LLMs using just SLMs. And this is again on that address.value similarity that we were talking about. There is still, however, a performance gap, like around 8 to 10%, or maybe if we compare GPT-4 or Mini, like almost 17% recall drop that we have, right? and almost 2-3% precision we are gaining, but at the cost of maybe 5-6% recall that we want to regain back. So how to improve this performance further, and probably answering the question on how we can get more data from this, that like Rajiv will cover on in differential privacy. Yeah.
Okay, yeah. Uh, right. So like typical with any ML model, I mean, without data, there are no data scientists. So although Rishabh mentioned that the synthetic data is available, but how representative is the synthetic data with the user data? How representative is the enterprise data? So that's the problem. Like ultimately we need the representative data. And like Rishabh mentioned that, yeah, we got good performance with fine tuning, but still there is a performance gap. Like rather than having say 90 plus precision recall, we were getting more like in the 70s. So how do we get more data? And of course, like we have lots and lots of data. We have customers' emails, and like I was mentioning in the initial slide, that the company store the data in the cloud. So all the data is available. Only thing is, yeah, we don't have access to the data. I mean, we can't read that data. We can't process that data on our own. We have to have customer permission and all, right? So that's where the privacy angle comes in. Sorry? Yep, absolutely.
Yeah,
So,
Microsoft bought it, and
absolutely.
the privacy policy says that all belongs to Microsoft.
Right.
So please go ahead. Please go ahead.
Yeah. Okay.
That was bought basically because of that reason.
Yeah. Not only GitHub, including LinkedIn and many other stuff. So please go ahead.
Yeah. Okay.
Let's not convert it into a social debate.
Absolutely. I agree. So the thing is, right. No, but the thing is that that's the core of privacy, in the sense that, yeah, you are not allowed to see the data.
There are business decisions to maneuver privacy concerns, and based on that we're taking the data and using it. That's absolutely fine.
Yeah,
That's
that's fine. And but I would put it this way, that, yeah, one way is that, yes, you can look at the data, and like that happened with the Enron email example which we were giving in the beginning. But customer data is eyes off data, in the sense that you are not allowed to look at the data. But data is available. That data can be fed to LLM, and you can get the insight for it. So how do we use that data for our model training? So that's where the privacy issues come in, and because the LLMs are known to hallucinate, if we feed those emails to LLM, it's possible that while giving the answers, it can use the training data, which is not allowed. Training data it should not remember. So how do we ensure that the LLMs don't remember the training data, but still use that data to learn about the entity extraction and give the answer? So that's where we are using a differential privacy. So we take the emails, and then like typical pipeline we mentioned in the beginning, that we have entity classifier, then we want to have a sample of emails so that we have enough samples, and then we can use the GPT-4 labeling. So this will be used to sort of get the label data or supervised data. But how do we use it for model training? Using differential privacy. So differential privacy, you can see it this way, that, yeah, using differential privacy by looking at the response at the inference time, at the test time, or at the time when you give some input and see the output, you won't be able to tell which data was used to train this model. So that's the crux of differential privacy. And like model output should not depend on presence and absence of individual users' data. So as long as we can say that, for example, if some output comes and that output may have come because of, say, these combination of more than 100 users or so, something like that, then we are fine, because then we know that this address may belong to any of those, and then we have the post processing to ensure that we don't do hallucination. Okay, so this is the definition of membership inference attack, that the result should not change based on the presence and absence of a particular user's email. Say for example, if we have two databases, D and D dash, and we have a model which is AD or AD dash, based on the output or subset of output S, we should not be able to say whether the D was used for training the model or D dash was used for training the model. So, differential privacy, typically what it does is it takes the large language model and then add new set of parameters, and those parameters are tuned based on the privacy budget. So this is a thing called privacy budget, that like, because we want to, while maintaining the privacy, we want to maintain the data useful. Say for example, if we one easy way of maintaining privacy is remove all the addresses from the email, but then the data set becomes useless. So how do we do the compromise between them? So that's where there is a thing called privacy budget, and the parameter which I mentioned in the previous slide, epsilon and delta, they are related to the privacy budget. So given the privacy budget, we modify the large language model or a small language model, and then what we have is a DP tuned parameter plus large language model, and that will in a way will be the differential private model, and which can be used for entity extraction. Rishabh mentioned that rather than modifying all the parameters of the large language model has the billions of parameters. If we want to train all the billions of parameters, it will require cost, and it will require lots and lots of data to train it. So we train only a subset of parameters. And this is the typical algorithm in which you use, any supervised learning technique where you have a gradient descent and you compute the gradient, and then there is a descent algorithm and all, right? So with the differential privacy, what we do is we concentrate more on what happens between the computing the gradient and the descent algorithm, descent part of it. What we do is whatever gradient you get, you add noise into the gradient, so that it doesn't depend on only few data sets or few data items. So these are the steps where you clip the gradient and you add the noise into the gradient, and these ensures that the membership attack, which I was saying, that just based on the output can you infer which data was used for model training, that to avoid that these techniques are used. Now as I said that we don't want to train the whole model or whole LLM, and we typically have modified only 0.5% of the model parameters. So that's so gradient clipping, because it's a costly operation, and noise introduced due to privacy grows as the square root of the model parameter. So rather than using the gradient clipping for all the model parameters, we use low rank adaptation, where in a very simplistic term, it is like you take whatever matrix is there, you represent matrix, the weight matrix W, as some L into R plus W dash, where L is the the row matrix and the column matrix, and W dash is the additional component of it. So we sort of approximate W as the L into R, and then we do the gradient clipping only for L and R, while ignoring the other thing. Okay, so this is the fine tuning with the differential privacy. Whatever workflow we had earlier, this is the probably the additional component where we have a differential privacy noise and the low rank adaptation parameters, and then we do the model training. And as you can see, for 5 class of models, which are in the range of 3 billion parameter model compared to say 1.7 trillion parameters of GPT, we are getting the performance of higher 80s like 86 precision, 82 recall, which sort of, I mean, we are not getting as good as GPT-4 model, which was like above 90 plus, but yeah, we are reaching there. So this says that yeah, if you have like, and you can see that the epsilon values here, the lower the epsilon value, uh, better is the privacy. So these numbers, and of course, I mean, everything comes with the cost. If you need the better model with higher privacy, then you need more data. So here we are using the data of 100K users, 100K, sorry, emails, and these emails are typically like we have some Microsoft users email which we are using. So thing, and that concludes our talk. And as you can see that as privacy budget of say epsilon equal to 6.7, as the data size increases, our performance sort of reaches the ideal performance. This is just wanted to show that how it converges there. Okay, so in conclusion, like I said, that the entity extraction is used for various productivity application, and because we want to make this system scalable from both number of emails and the number of entity point of view, so we are using the language models, and large language model of course work fantastic, but there are a lot of social concern, cost concerns and all. So we don't want to use large language model for each chota applications or something. For some application we can use the small language models, but a small language model of course have the performance issues. So using fine tuning we can improve the performance. Now fine tuning, there can be issues that whether you do the fine tuning, then will it become very specific to a particular entity extraction? Can we do the same fine tuning or same model for say multiple entities? Like we are extracting some 10, 20 type entities. Can we use the single model for all the entities? Whether we can take further smaller model and do the entity extraction. These are the continuing work which we are doing. Thank you.
Let's thank them, and then since we are really shooting over the time limits, I'll limit the number of questions that you may have, but please, the floor is open for questions. I know some questions were asked during the talk, but if there are any other questions, maybe 1 or 2 questions we can have now.
Can you use ensemble of small LLMs to improve the performance? There is the scope, do you think?
Rishabh, you want to take?
Sure. So yeah, it's a very good question actually. So the issue that we have right now is that we can actually take out the weights, but we are not planning to actually take out the weights from different small language models and probably create an ensemble. The idea is that it should be cost effective. If we are planning to say use 10 small language models, then we are probably moving towards increasing the number of parameters more, then it might not be as cost effective. But yeah, from the performance point of view, we can definitely.
Energy cost, you are saying energy cost or?
No, GPU cost is still there. So like
It's a compute cost, compute CPU.
Compute cost, yeah. So it is still there. It's just that like if one small language model is able to do the task well with the given performance metrics that we have, then we might not try it. But like for some entities such as task, we are not getting as good results. So maybe for that ensembling might be an option. So yeah, maybe a future scope for trying that out. Yeah.
Sorry?
What is the small language model? No, what is the small language?
Oh, that is like a language model with like 3 billion parameters. That is small.
Lesser parameters, yeah.
Whereas large language model is like 1.7 trillion
Correct,
parameters.
correct. Yeah,
So
Llama is a good example.
Llama is
yeah.
Cost estimation has been done between the, say for example, if you say that I employ a co-pilot, right, for planning my travel to Jodhpur,
yeah,
or I have some personal assistant who can help me in
right,
finding out what are my present day tasks, etc.
right,
So there is a cost involved in that.
yeah,
Now there is also a computational cost involved if I use a co-pilot.
absolutely.
Whether there has been a kind of a trade-off that has been done somewhere.
That's
if I employ a human being, what is the cost, and if I don't employ a human being and employ a computer,
yeah.
what is the cost involved there?
Okay, first of all, yeah, as far as the quality is concerned, I feel LLMs are much more reliable than human beings.
Yeah. We've seen some samples where LLMs
right.
even outperform. Because so it's
I don't know how many years love talking to an IPR. I have seen in banks.
Yeah.
Okay, I have a crisis.
Yeah.
I receive a spam call.
Absolutely.
Which says that somebody used your card and they just imitate completely like my bank.
Right.
Okay, some 78,000 rupees.
Mm-hmm.
If you think it is invalid, press 1.
Oh,
I don't have any choice other than pressing 1 because I don't know.
Yeah.
And then machine starts talking. It took me hours to really validate.
Fully agree.
So the question is, by blindly going and making a statement or trying to, say that productivity, also along with the productivity, when I go to a doctor, I want a human touch.
Absolutely.
I want a human being
Yep.
listening to me, not a machine listening to me.
Makes sense.
So there are many of such examples
Right.
which need to be considered. Thank
Absolutely. You are right. You are right. So the thing is, yeah, of course, blindly we cannot adopt this, but like for some of the tasks which are becoming like, I mean, the data is there, it's there in your email, it's the, like, if you can see it as a more of a search plus kind of problem, right?
Correct.
In that case, you will feel better in the sense that, okay, we used to do the Google search or Bing search, now rather than searching it, we are getting the answers.
Yeah.
Now, from the answers, I mean, I can do the data analysis or maybe like whatever is there on the web, I can get the kind of question she was asking, whether giving particular GDP and the say equality, they are related or not. We can, I mean, machines can give at least that answer. After that, how to interpret it, the humans are required. Like for example, I mean, lot of radiological tasks can be done by the machine. They can give you the guidance that, okay, out of these 14 diseases which can be there, lung diseases based on the chest x-ray, these are the higher probable. After that, doctor can come and give the proper guidance or the treatment.
So human is still in the loop, by the way. Even in Copilot, like it's just kind of an answering machine for you. At the end of the day, what do you want to do or how do you interpret that answer? That's pretty much up to the human using it.
So that's what I'll coming to that. So that's a good question from the point of view that say or like the example which you were giving, that how much value add we are getting from the productivity applications and how much cost customer is saving versus how much cost we are paying for GPUs and all. I mean, I don't think that kind of analysis is there yet, but probably we will reach there. I mean, I don't think we understand the full applications and full implications yet to go there yet, but I mean, like even these kind of queries, still these products are very nascent stage. They are just a lot of enterprises just evaluating these products and what are the different application it can be used and all. So yeah, at this point, I don't think I can answer those questions.
Original training data. So I just have a question, like initially you have shown that there are 6,000 parameters before actually generating the synthetic data.
Tokens. Yes.
Yeah, tokens. So how do you define that, okay, for this amount of data set, I have to generate this many synthetic data. So do you have any ratios you can, you are generating this much amount of synthetic data for this set?
No, no. So first of all, like that 6,000 is the number of tokens that the prompt requires.
That's the prompt size.
Correct.
What instruction do you give?
So when we use the model directly, which is pre-trained on world knowledge, then we require an elaborate, detailed token to make the model understand, what the problem is. However, when we fine-tune it, then that prompt size reduces to something like 10 tokens. So that was that 6,000 thing. Other than that, with respect to the data, right? So when we talk about these privacy budgets, so when we reduce that privacy budget, right, like we cannot leak privacy as such, as Rajiv discussed that that epsilon value that we were targeting. Whenever these epsilon values go lower, accordingly we need more data. So since we are using a very low epsilon value, like industry standard is something like 6.8 or 8, right, for MMLU datasets and MNLI datasets, they have used those. But like Microsoft standards for privacy are typically higher. We try to convince our customers that we are using a private privately compliant thing. So that's why we are using that epsilon value to be 4, and that's why we kind of need to increase that data set from, say, initially we had 20,000 examples in that synthetic data that we trained on, but then we increased it to 100K with that differentially private system. Yeah.
I think we'll have to end the session here unless we want to reduce the lunchtime too much so it becomes impractical. So I wish to thank the speakers again for what has been a very thought-provoking talk, and also something that from the questions we can see has generated a lot of discussion. Yep. So thank you very much.
We are going to talk about predictive big data analysis for supply chain management and demand. So we will start with that online presentation. Yeah, can you please
if you can just confirm if my presentation is visible. Yes, it's visible. Thank you. I'm here to present my paper on an efficient predictive big data analytics for supply chain demand forecasting through ensemble learning. First of all, thank you for 12th International Conference of Big Data and Artificial Intelligence for this opportunity. Also, my project mentor, Venkateshwaran, and Indian Institute of Information Technology, Kottayam for all the supports till now. Okay, moving on to my presentation. So in this presentation, I'm just explaining the outline I'm going through. The first one will be an introduction, followed by literature, statement, objectives, proposed methodology, dataset description, experimental and result and analysis, conclusion and future work, and then the references I have gone through for this paper submission. So coming to the introduction, from the heading, you might have understood that the domain I have selected for this particular project was supply chain management. As everyone knows, supply chain management facilitates the flow of goods, services, and so when it actually deals with the goods, service, and information, any uncertainties in the capacity, demand, and cost will have massive impact on the supply chain management process. That's when the demand forecasting is so crucial in performance. Happening currently is the real world uncertainty is a great challenge to traditional supply chain management and its demand forecasting methods. Statistical analysis like time series and regression analysis have been employed for demand forecasting in SCM currently, but the limitation of a conventional numerous parameters influence the demand. And any partial understanding of demand variation are actually less adept at handling the nonlinear behavior, which is prevalent in supply chain dynamics, because any data that we are dealing mostly in supply chain management is always having different factors and it is moreover a nonlinear behavior. Okay, that's where the big data analytics comes to picture, where it uncovers insights of accurate forecasting. Also, BDA enables us for precise prediction on supply chain management. It also increases scalability, efficiency, and it makes the data processing easy. So while coming to the literature review, all these papers I have gone through, I tried to learn about what all are the different type of ML algorithms that we can use for different type of demand forecasting models, how we can deal with the different the supply chain data which is having a seasonality on it, and what is an ensemble learning, how can I combine the results of two different ML models or algorithm to a single model and can come up with a more accurate or efficient prediction. So these are some literature papers I have gone through to gain this knowledge. Well, coming to the problem statement, as I already explained, effective demand forecasting is a critical component of supply chain management that has a direct influence in operational efficiency, the cost reduction, and the customer satisfaction. But however, the business often faces challenges such as inaccurate predictions, delayed responses due to market dynamics, and underutilization of advanced analytic techniques. So the problem was with the traditional forecasting approaches, which frequently falls short in handling large, complex, non-linear data sets or adapting to rapidly changing market trends, which was a shortcoming of this. Furthermore, the lack of integration between geospatial data and forecasting model limits the accuracy and relevance of predictions in location-specific demand scenarios. Additionally, business struggled to harness the full potential of big data frameworks. As everyone knows, big data was not part of most of the organizations. It was only accessible, or it was only used by big trades because of its cost and other reasons. So now, due to the help of cloud, if almost all adapt that big data framework. So advanced predictive analytics to achieve this scalable, efficient, and high-performing demand forecasting is now open for all the enterprises. Then coming to the ensemble method, we do an ensemble method with geospatial integration in big data analytics through promising remain underexplored. So this was not ever explored in this context, leaving a gap in optimizing forecasting accuracy and reliability. That was the reason why we tried to make use of big data analytics for the supply chain demand forecasting. And what is the objective of this project? The objective of this project was to provide a valuable insight and recommendations for business, aiming to enhance their supply chain demand forecasting and operational efficiency using predictive big data analytics. First, we started with a systematical study of various algorithms used in demand forecasting for supply chain management. Then optimize demand forecasting with ensemble methods. Also try to integrate geospatial integration using clustering for improved accuracy. Also to leverage the big data frameworks for performance enhancement. Moving moving forward to the data set I have used over here, the data set I have used is Iowa liquor sales. As a brief description, this data set contains the spirit purchase information of Iowa Class A liquor licensed by product and date of purchase for almost 11 years, and it was approximately having 29 million rows. The total number of features in the overall data set was 24, but for this particular paper or project, I only made use of 10 that is mentioned over here. Also, I have performed the analysis of variance testing used to generate. ANOVA was performed to find the F value and P value to make sure that it is having a stronger relationship with target variables and making sure that statistically there are significant difference between the groups and it is not by a chance. So we were able to identify that features which we are going to use is having higher F values and lower P values. Coming to the proposed methodology, as I already explained, I have selected the input data set of Iowa liquor sales. Using that data set, first I have done a data pre-processing steps just to make sure that we are not having any outliers, the null values are removed. Also make sure there is proper scaling happen for the feature so that we won't be having any anomaly later. Then we moved on to the feature engineering where we have done the feature extraction and feature selection. In case of feature extraction, we have made use of the existing longitude and latitude data to come up with a new feature called as clustering with the help of k-means clustering technique. And for feature selection, we made sure that what all feature selection we have selected from the existing one will be helping us to come up with a better quality supply chain demand forecasting. Once we have completed with the data pre-processing and feature engineering, this prepared data set has then set for seasonality test. Anyway, supply chain management data set normally shows a seasonality by knowledge, but still we have done the seasonality test just to make sure that the data we are going to use is seasonal. Then we have processed the data. The next first step I have done is a k-means clustering to come up with a new feature clusters for the geospatial integration. And to identify the optimal k value, I have made use of Silhouette analysis. Then this data has been fed to the different learning models for Sarima, also the Prophet. Then we have done parameter optimization using the grid search to make sure that we are increasing the accuracy or the results of the learning model. Then we try to come up with the ensemble approach methods to combine the results of both the learning models and then a model evaluation using the MSC, RMSC, MIE, and MAP. And it was integrated in a big data ecosystem using PySpark. And we come up with the prediction results. Seasonal decomposition I have performed. In the experiential resultant analysis, the geographical similarities in demand patterns are identified by extracting the new feature cluster. As I explained, we have made use of the existing latitude and longitude column in the existing data set to come up with the clusters. So the geographical similarities in demand patterns are identified by extracting this new feature. Also, it helps in understanding the spatial patterns in the distribution of orders and can aid in optimizing the logistics and resource allocation. So just to make sure that we are doing the proper clustering and we are not making any computational mistakes, we made sure that the latitude and the longitude coordinates in the data set are standardized before going on with the clustering using the distance metrics. So here, currently you are seeing the result that occurred from the first model, which is using k-means for clustering, Sarima for learning, and the grid search for hyperparameters and tooling. You can tell, you can see that initially all the values were high while we was doing the normal one, but when I performed the hyperparameter optimization using the grid search, gradually the count came less and with a lesser MSC, RMSC, and MIE and MAP with a better results. Moving forward, the second model was k-means for clustering, Prophet for learning, and grid search for hyperparameter optimization. Here also, initially the default value was really high, but after hyperparameter optimization, we were able to come less with that. And this particular model was outrunning the model 1 as per the results. Then we came up with the ensemble model approach. We tried to harness the results we achieved for both the model 1 and 2 from the hyperparameter optimization grid search to the ensemble model using weighted average, simple average, and linear regression. And as you can see the results over here, linear regression was having the lesser value and having more accuracy and efficiency in the result part. Reaching the conclusion of this particular paper and the project, we were able to commission predictive big data analytics for supply chain demand forecasting, the ensemble approach. The geographical similarities in the demand pattern is identified using k-means, and the optimal k-value came up with Silhouette analysis. Also, the demand forecasting done using the SARIMA and the Prophet models. The optimal parameter tuning was done using the grid source. Furthermore, to enhance the forecasting accuracy, the ensemble method, simple averaging, weighted averaging, and linear regression was explored. Initially, the proposed model is experimented in 5-node Spark cluster deployed in the cloud for Iowa sales dataset, as I already explained. And we evaluated that using the matrices like MSC, RMSC, MAE, and MAP. The results suggested the SARIMA could achieve the lowest in MSA among the SARIMA models. During the hyperparameter tuning using grid search, improved the performance of k-means and Prophet model. Further, while we done the during the ensemble approach, it outperformed all the other techniques in terms of accurate metrics. So what is the future work? Actually, I was planning to do this project for my company where I'm currently working. So currently I'm working supply chain management. So this was like a real life issue that I was actually seeing during my working. So that was the reason why I came up with this particular topic. And as a future work, what we are planning is to employ other hyperparameter techniques like random search, Bayesian optimization, and genetic algorithm, just to make sure that we will be able to increase the efficiency. Also, to explore the integration of advanced machine learning techniques such as deep learning, the tools and techniques like LSTM and GRU for further model improvement. We are not ending up with this Terima and Prophet. We are going to explore it with a more advanced machine learning to check that we will be able to achieve more accuracy and efficiency in our demand forecast. Also, we are also planning to develop an interactive visualization dashboard and alert system for real-time monitoring and decision making, because end of the day, whatever we are doing or what we need to predict is actually for the business team. So it is really important that we should have an interactive visualization dashboard and alert system so that the business will get well alerted and it will be more easily understanding for them to take an actual business decision. So these are some reference books I have gone through during my project work to come up with this presentation. Yeah, that's all. That ends my presentation. Thank you once again for everyone for this opportunity.
Any questions from the audience? Since let's move to the next topic.
Thank you, Srini.
Okay, the next talk is on stock price prediction. It's paper 31. So we have Jayant here from BITAP. So let's start.
Okay, good afternoon to all. My name is T. Jayant, under the research supervision of Dr. A. Manimaran, BITAP University, and the title of my paper is Enhanced Stock Price Prediction with double exponential smoothing with encoder decoder bidirectional GRU using smoothing maximum unit activation function. So these are the contents of my presentation: introduction, literature and dataset description, proposed methodology, experimental setup, results, discussion and conclusion, reference. So from coming to the introduction, involves buying, selling and issuing public trading of shares is crucial for the stock market dynamics and influenced by the behavior of stock trading. They may be positive or negative stock market and politics, corporate performance and global economy of complex factors are challenging to the predict the stock price prediction. And from coming to the significance of accurate stock price forecasting benefits in investors and reflects to economic health. And for using the advanced technologies ML and deep learning models to improve the accuracy of the stock price prediction using the SMU activation functions. For my proposed model, that is the hybrid model, double exponential smoothing ED by GRU using with the SMU activation function. So from the literature review, we reviewed to the traditional statistical models and the hybrid models, deep learning models, recent technologies also. From the traditional statistical models, simple exponential smoothing, Holz exponential smoothing, Holz winter exponential smoothing and ARIMA. These are the getting the RMSE 72.84 and MAP 6.26%. From coming to the hybrid models, compared to the statistical models, hybrid models getting the more efficiency. Hybrid model, that is the seasonal ARIMA, combined with the double exponential smoothing, it will get the PICP score of 95.53%, and the deep learning models, that is the context ABT by LSTM CNN with 0.973 accuracy and multiple TCN and TPA LSTM are get the more accuracy. For our proposed model, we use the general electric stock prediction with various time stamps, that is the daily, weekly and monthly stock price prediction. From the data, we are first collecting from the data, we are clean the data for handling missing values and finding any outliers. After that, we are normalizing and scaling the data with uniform the same data. After that, we are exploring the data analysis for any trend for that any outliers or trend in positive or based on the exploring data analysis, we will get the how the data is presenting. After the pre-processing, we split the data into training and testing with validation and hyperparameter tuning. This is my proposed methodology. From collecting the raw data, we pre-process the data. After that, splitting the data. Then we will come to the hybrid model. First, we use the statistical model, double exponential smoothing. After that, encoder decoder. In the encoder decoder, at the hidden layer, we use the bidirectional GRU for free forwarding and back propagation for past and future values. After that, we are using the SME activation function to predict the hybrid model. For that prediction, we evaluate the metrics MAE, MSE, RMSE, MAPE, accuracy, R square and tails U statistic, which are the forecasting evaluation metrics. When coming to the experimental setup, we as said that we first use the double exponential smoothing for the pre-processing stock price data to capturing the linear trend and smoothing fluctuations. After using the for smoothing data, for using alpha and beta. For alpha, it is controls the level and beta manage the trend smoothing. After that, we use the ED by GRU for nonlinear prediction model that captures the both past and future dependencies of the stock data. For using the SMU activation function, that is the SMU is of x equal to x by 1 plus e power minus x. This is the double exponential smoothing. Here we are using the alpha, two different type of alpha and two different type of beta with four possibilities compared to the actual data. For the evaluation matrix using to the three different type of data set, daily, weekly, monthly. Here the using tiles use statistics, our proposed model get the lowest value. For the tiles use statistic evaluation matrix, it is lies between the 0 and 1. When the matrix comes to the nearly equal to the 0, our performance, that means our model get the best accuracy. When it far to the come to the 1, it will goes to not good. When from the results, for it is the using the General Electric stock price prediction data with daily and weekly and monthly data. When compared to the three data sets, daily data set is the get the good accuracy and prediction values. These are the evaluation metrics are used with compared with some deep learning models. From the discussion, our proposed model is getting the good accuracy based on the performance of evaluation matrix using the SMU activation function. When taking to the tiles use statistics, the lowest value of the General Electric daily data is 0.007 compared to the other weekly and monthly data. When conclude that our proposed model is demonstrate experimental accuracy in prediction daily data and combined with the double exponential smoothing and ED by GRU using the SMU activation function with achieve lower error values and high accuracy. For my future work, we are effectiveness across the various financial data sets, and we are also planning to the attention mechanism also. These are the some selected references. Thank you. From Yahoo Financial, publicly available data, Yahoo Finance portal. From starting in that portal, from starting to that day, when we are downloading the day, that from that day. That means from 19.
BSc started?
Oh no.
So you have worked on around 45 years of data, is it?
No. That is 20 years data.
20 years.
That is only available in.
And you have taken every stock prices, every stock graphs into the system.
Yeah, yes.
Right? Yeah. And based on that, if I am correct, you will be giving one particular input and the model will be generating what will be the forecast for it for next one day, for a week and for a month.
Yeah, yes. But we are actually predicted only training and testing, not for future. That is the future work we are working on that.
Thank you.
Thank you.
It's a very nice work. Nice presentation.
It is the hybrid activation for combined with the relay activation and softmat activation function, which is better than they both. When compared to the time complexity, when we are training the data set, it will less the time complexity.
Your efficiency in terms of the time complexity only.
Yeah.
Did you try any other SMU functions, like just other than e to the x divided by 1 minus that function? So did you try some other function as well?
No, that's really this one. Yeah. That is this is 7 features around and 35,000 get the good accuracy compared to the weekly data and monthly data. Daily data get the good accuracy.
Thank you for your presentation.
Thank you for patience listening.
Paper ID is 52 and yes, it's real-time pothole detection system. Please go ahead.
Good afternoon to everyone. I'm Ajay from Vasvi College of Engineering, and in the guidance of our professor and assistant professor, we did a project real-time pothole detection. We are with the SSD, and if we come to basic abstract of our project, it's in India we can see potholes as a major issue in on the roads because there are many accidents that are happening due to potholes, and after even though they are doing their best to repair them. If after every rainy season we can again see the new potholes on the roads. It's it's a continuous issue in our country, and to solve that we developed a model, a real-time system using SSD to identify the potholes, and that can be updated on a Firebase where government officers or any user can also update the location of the pothole and with an image, and the officers can verify the pothole, and they can issue some solution to clearing the pothole or some other solution. And this study is centralized, it's creating a platform of pothole detection using Neo 6M GPS module and ESP32 camera modules. And the Neo 6M GPS module is used for tracking the location of pothole, and the ESP32 camera modules are used to extract the pothole image and send it to the model. The main challenge that we are addressing is road damage, which is road damage detection and reporting. So by using this model, we can easily we can simply give it to traffic cameras, and it can detect the pothole, and it can update it in the Firebase our database, where anybody can access and see where the potholes are present. And if any user want to we have also integrated it with a Google Map. So if any user want to go on from one location to another location, he can access this and see how the road is, and how he can easily travel from one location to another location without any without any potholes on the roads. And the planning will be easier for drivers. The main thing about this system is to ensure road safety and minimize the vehicle damage and accidents. For this project, we basically did literature survey based on the papers on SSDs, and integrations of SSD with ResNets. So what we came up with is how ResNet ResNet 34 can be integrated with SSD to easily extract features and give more accuracy, and how SSD is better from faster RCN when compared to because faster RCN is a two-stage detector, whereas SSD and YOLO, all these are one-stage detectors. And why we choose SSD is basically it excels in balancing speed and accuracy when compared to YOLO models. And SSD has gone extensive study and improvement. Various works have optimized its architecture, and what we added is ResNet for extracting the features, and added it the extracted features are sent to SSD for evaluation and creating bounding boxes. And in the dataset we also added data based on changing the lightning and adding more shadows to the dataset, and also we also transfer the images from color to gray light so that it can be visualized as the model can be trained on diverse dataset. And we also adjusted hue conditions or everything to make the model not to overfit and have diverse conditions to like diverse conditions. It can identify the potholes. The main steps in our proposed work is first data collection and pre-processing and framework and architectural model, and we split the data we have collected into custom data sets, and after training the model we tuned the hyperparameters to get more accurate results, and we integrated it with Google Maps for analyzing damages that are reported. So the basic methodology of our project is to collect data collection and labeling the images, and we are basically training them. Like before training them, we have augmented the images, so we can get more images from the present ones. And in augmentations, we used augmentations module Python library, and we split the data set into training, testing, and validation data sets, which are like 70, 15, 15%. And after training the data set on result model, we given that we transfer the learning capabilities of that model to SSD, and we easily predicted the bounding boxes. And in real time, what will happen is EST32 like a ESP32 camera module captures the images, and it will give the model to Resident 34, which extracts the features present in the model, and the extracted features are given to extra feature layers, which creates the bounding boxes. Like the SSD creates the bounding boxes in the model, and the models, if they predict a pothole is present in the given image, it will update it into the Firebase database, and after that the camera will be off for it will be turned off for 24 hours, because we don't want to send same image to the database multiple times. And by using Neo 6M GPS module, we are also updating the location in the database for clarifications. And the data collection and pre-processing in this step is like we collected data set from Kaggle, which has a 700 plus images. We labeled the images with using label.me, and stored the labels in XML format. And these 700 images are like we did augmentation and increased the number of images from 700 to 2000 for training purposes. And for augmentation of images, we basically used augmentations of data sets, where we did different features on different types of different things on different types of images. For some of images we did random cropping, extracting some of the features and cutting some of images, and we also used grayscale conversion to transform images to grayscale for easier for making the model diverse. And saturation adjustment and brightness adjustment are used for different brightness, because in real time at any time the model needs to accurately predict the pothole, and hue adjustments, shadow adjustments are done to give it a realistic effect. And in nighttime simulations also, nighttime images are also given to the model for the model to work in diverse conditions. And the framework we used for this paper is to model is PyTorch, because SSD is basically developed on TensorFlow. We want to try it on different framework, and we tried it with PyTorch. And the architecture is ResNet, which is for a feature extraction and identification of features, and which is given to model, which is SSD. And by training the SSD model with on our custom data set, we trained it on different optimizers and learning rates. And initially the model, when we trained the model, it used to give us a less results, but by hyper tuning we got the wanted results. And the best results are given when we used SGD loss function with a learning rate of 0.0005 and a momentum of 0.1. The result we have achieved is 8.676 map score, and with a train loss of 0.6764. And we also trained the dataset on different models for a comparative study. And from what we trained on YOLO mini models and nano models and large models and extra large models also, the overall results are not as satisfied as for a SSD model. So we choose a SSD model for the prediction in real time. And these are the results we obtained in our training of models. And these are different hyperparameter tunings. In the first image we can see the momentum we took was 0.1 and our learning rate is 0.001. and optimizer we took was Adam optimizer in the first image, where we changed the momentum and optimizer in second one, and the optimizer is again changed in third image, and the best results are occupied in fourth one, like 0.1 momentum and SGD optimizer with a learning rate of 0.0005. These are the images like results. Here as you can see, the potholes are detected with some confidence levels, and they are updated in the website here, and when we click on the location and the map, it will show where are the potholes present in the location, like a route, and officer can easily send some members to repair or do something on that potholes. And this is the like interface where we can where the officers can see present like where the data is from, and how the situation is, and also like on the map they can see the location, and from camera ID they can notify that like from which area the images came which image came from. And the conclusion of this this is my, the basically the conclusion is we did a resonant model integrated with SSD for high accuracy predictions, and but there may be in future there may be some new models where which have more accuracy, which can be easily predict the manners, and I guess that's the future scope of the project. The basic software and hardware requirements of the projects is Python 10, and the main libraries we used for capturing the images are OpenCV, and PyTorch is used for model implementation, whereas augmentation and level me are used when during augmentation and labeling of the images. SSD is the basic model of our project, and Google Colab is used. Generally we used Google Colab, but we can also replace it with a system with GPU, working GPU, and the hardware requirements are ESP32 and ESP32 for data transferring, and Neo 6M GPS module and a TTL for data transferring and capturing the location.
My question would be how exactly the single shot detection is coming into play. Like why is it better than other say, like one level learners?
Sir, if we want to use, we can use fast CNN or RF CNNs. But if we use that, time to predict the like image where pothole is present will be more compared to one stage detectors like SSD and YOLO. And in the one stage detectors, we have compared the SSD is giving high performance compared to others. Like YOLO, we basically did it on different types of models. YOLO V5 mini models and small models and nano models also. And we also did it on YOLO V8 models. And based on our results, the more like the model that is giving highest accuracy is a SSD model.
Thank you. Talk of this session is from IIIT Lucknow. Akanksha Singh is presenting the talk, so it's air quality and pollution prediction of urban areas.
Good afternoon, everyone. Good afternoon, everyone. Am I audible? Good afternoon, everyone. My name is Akanksha Singh. I'm from IIIT Lucknow, research scholar, Thank you so much for giving me this opportunity. Today I'm here to present my paper that is based upon data analysis with model explainability for air quality and pollution prediction for urban areas using edge networks. Moving on to the first slide of the presentation, we have the outline of the entire PPT. We are going through it. The first slide will be from the introduction, research gaps and objectives, methodology, system model, experimental analysis, conclusion and references. Moving on to the very first slide, we have introduction. Basically, air quality prediction is very crucial for safeguarding the human health, for protecting the environment and reducing the impact of the pollution on human health and economic stability. Accurate air quality prediction is very essential for public health because in the urban areas already the air quality is at a very alarming rate due to rapid industrialization and urbanization. And accurate and local predictions of the air quality is very helpful for mitigating all such issues of health analysis and the economic stability of the nation or the local area. Moving on to the continuous slides, we have associated problems and the current state of knowledge in the terms of air quality. So as I was saying that we have associated problems with the air quality. The very first problem which we generally face is the current ML models struggle to predict the air quality accurately in the urban areas because the smaller section or the microenvironments of an urban area has different contaminant levels, have different geographies and meteorological conditions. So each and every smaller subsection of an urban area has different types of problems that are associated. Because of that, the standard ML models are not able to predict the smaller microenvironment air quality. The second challenge which we generally face or the associated problem with air quality is that the standard ML models are generally trained on the generic data, not on the precisely on the local data of that particular microenvironment. Similarly, the resource constrained edge environments or the edge network are not able to handle large amount of data or large dimensionality of the data because of constraints of computational constraints and storage constraints. So because of this, these are the basic associated problems that are generally seen in most of the research and the papers that are being present in the field of air quality. The current state of knowledge states that the existing model have large-scale generalized data set that are usually processed in a centralized location of cloud processing, and the new approaches like data fusion or localized edge network computing are being accepted in the field of air quality prediction also, but the challenge of feature extraction and the multiple dimensionality of the data still exist in most of the papers. Therefore, we have suggested a hybrid model of the entire system in which we are going to use the cloud and edge based computation that will be hybrid in nature. Moving on to the next slide or the next section of the PPT, we have research gap and objectives. Primarily, there are three research gaps that are being identified while going through the literature surveys. The very first is limited computational capacity of the edge network. All the edge networks are having limited computational capacities as well as the storage capacity. Similarly, local versus public data. Generally, what happens is that we tend to train the model centrally on the cloud with the public data, but the microenvironments have different type of contaminants and have different type of geography. The similar city itself can have different types of pollutants within the city itself. Therefore, localized data should be used for prediction. Third thing is the third research gap that is being identified is insufficient data for robust model prediction. We generally have a similar type of data from a similar location and therefore the data is biased sometimes. Therefore, having different data from different time zones or different area of a city is very crucial and important. So these are the three research gaps that we have identified. On the basis of these three research gaps, we have made these three research problems and the three hypotheses that are going to resolve or mitigate these problems. The very first was insufficient data. For that, for the removal of insufficient data, what we have done is we have used the data from APIs. We have fetched the data from two APIs and the public data that was available on Kaggle. We have used data fusion methods or basically data concatenation to have to address this issue of having limited or similar kind of data so that we can remove the biasing in the data. The second hypothesis states that the standard ML model were trained on the cloud itself and the prediction was made on the cloud itself, not addressing the microenvironments. Here what we have done is the standard ML model will be trained on the cloud, but the feature extraction methods will be implemented to identify the key features, and those key features will be deployed on the edge environment or the edge network, so that there the local data can be collected using sensors, and there we can have that proper implementation and prediction at the edge, which will be conducted in the future aspects of the project. The third aspect that has been as a problem statement that has been identified is that there is lack of transparency in the overall prediction. For that, for removing this issue, we have used explainable AI for removing the for adding transparency and adding the interoperability between the decision making and addressing this entire issue. Moving on to the next slide, we have methodologies. Basically, we have three problem statements and therefore three contributions. The very first is data fusion, for which we have used API data and publicly available data. We have fused the data, and the equation for that is given here. That the total data, that is, we are going to create the test bed on the basis of the public data and the API data. The details are given on the further slides. We have been collecting these data, and we have fused this data all together to form a generalized test bed, and this test bed is further used for this test bed and further goes for data pre-processing and cleaning the inconsistencies, cleaning the data set, and removing the missing values. The second contribution states that the overall prediction or overall training of the initial standard models will be held on the cloud, and the feature extraction methodologies will also be held on the cloud itself. For this, what we have done is we have used 4 standard ML models, that is KNN, SVM, random forest, and decision tree. These are the 4 basic models, standard models, which we have used. We have trained these models on the data that we have collected after data fusion, or we have created test bed after data fusion. Once these models are implemented, we have implemented the feature extraction technique, that is mutual information. Mutual information is the method by which we identify that what are the particular parameters that are going to impose more effect on the prediction or the resultant we are going to target. So using this mutual information method, we have identified the key features that are more important for this prediction. After these key features are identified, we are going to train the models after removing all the unnecessary parameters and features, and only the necessary or selected parameters are used to retrain these models, and the models are compared before and after on the basis of the performance matrices, CPU and memory utilizations. And post this, the best models and the best model and the best parameters or key parameters are transferred to the edge environment. In the third contribution, what we have done is we have used explainable AI, that is SHAP in this particular case, for maintaining this, that the entire working of our project or the entire flow of the project is correct, for making this entire transparency in the decision making. SHAP tracks the features like SO2, NO2, etc. All these features, it tracks all the features and identifies that which particular features are posing more impact on the feature, on the prediction that we have made finally. So a little bit of detail of SHAP. Basically, SHAP is a explainable AI method. There are 2 methods, SHAP and LIME. We have used SHAP here. And what SHAP is doing, what is the relevance in our model? SHAP is doing 3 things here. First, model transparency. It is providing the transparency within the layers of the model. The second thing is feature importance, which features which we have identified using mutual information are the same features that are identified using SHAP. And the third is model validation. We have used SHAP for 3 things here. Moving on to the system model, this is the architecture of the system model. If you can see, first of all, we have done data fusion of the API data and the publicly available data from the Kaggle. Then we have used this data to train our standard models, that is KNN, SVM, random forest, and decision tree. Post this, we have used feature extraction methods, and after feature extraction, we have identified the key parameters and retrained our model. After retraining the model, we have compared both the models before and after, like retraining on the basis of performance matrices, and the best and optimal model with the optimal parameters and key parameters are sent to the edge network, which will be sent in the future to the edge network, where the local data will be collected using sensors. This part is not implemented as of now. It will be implemented in the later on stages. The third part, that is implementing the entire process or entire working on the edge network using this, collecting the data using the sensors. So this is the overall system model. Moving on to the experimental setup and data set, we have used these 4 standard models, that is KNN, SVM, decision tree, and random forest. The performance matrices are F1 score, recall, precision, and your this recall. And in the test bed, we have 3,000 records, and the data of the test bed, which we have identified as the prime parameters, were CO2, CO, NO2, SO2, and PM10. According to a report published by WHO in 2002, it was already identified that PM10 is a primary pollutant that is causing approximately 20,000 lakhs of deaths each year just because of PM10, that is particulate matter 10. Moving on, we have trained the data, and we have divided the data into training and testing beds, and we have trained the data, and finally we have used SHA to implement the transparency. This is the resultant. There's no major there's a very slight improvement in the entire working. If we can see that there is a very slight improvement in the terms of accuracy, precision, recall, and F1 score in mostly all the algorithms which we can see here. The overall improvement is not that big enough, but yes, there is a slight improvement which can be further removed, or which can be further more enhanced in future terms. Moving on to the last part, that is conclusion. We have created this entire study as a basic foundational process to create a robust model that will be having the localized data set at the edge network using Raspberry Pis and using sensors later on. This is the foundational step. We will be completing this project later on. And other than that, we have used API data and publicly available data sets. We have created this entire proceedings with the help of data pre-processing and data consistency and quality. Further, we have used this approach to ensure that the resultants are unbiased in nature, and there is high accuracy and precision in our overall resultant. The future scope of our project relies in federated learning. We are planning to implement federated learning in the entire proceedings, where each of the individual local edge network will be collecting the data, it will be performing the analysis, and further all the entire data will be sent onto the cloud so that we can use transfer learning or federated learning on the cloud itself. Moving on, the next future scope will be emerging technologies that I have already told that we are planning to use IoT and AI in the upcoming stages of this project. Scalability, we can scale up this project to a much higher extent of a bigger section of an urban area, and energy efficiency is the next step which we are planning to confirm. That is, we are going to analyze what are the latency issues that we are going to face between the cloud and the edge. Along with that, we are going to analyze that what are the energy efficiencies and how we can maintain the energy in the entire working of the project. These are the list of references which we have gone through while creating this entire project as of now. Thank you so much for your patience hearing. Actually, while doing this, while creating the test bed, we had we had major constraints, like we had to take the data from a similar location, which was not possible in the case of publicly available data set. And similarly, that was the case with APIs also. So for the foundation,
So this ends this session, and we will be having the closing session of this conference on today at 4 p.m. So please be here at 4 p.m. today, and Professor Srirama will give the closing remarks of this conference. Thank you. So we have.
Yeah, now it is. Now it is working. Thank you. So, good evening, everyone. Okay, thanks for staying until the end. Okay, so hope you enjoyed the last 4 days of conference. Okay, Big Data and Artificial Intelligence 2024. Lot of interesting sessions, lot of interesting keynotes. Okay, industrial talks. Okay, and we have at last come to the closing session. Okay, very happy that the way things have proceeded. Okay, from University of Hyderabad side and from the general chair side. Okay, we thank you all. Yeah. I'm starting with that.
Yeah, hello. So welcome. So I'm a steering committee chair of BDA series of conferences. Next year we are going to have a conference in July and August in IIIT Bangalore. So all of you are requested to submit research papers. Each one of you are welcome to visit Bangalore. We will have more exciting conference there. This is thank you.
Okay, thank you. So last few bit of things. Okay, so one thing which we have not given is like where is our workshop chair? Chenmaya? What he is still doing? Yeah, somebody please call him. No, he was here. He was here. He was up the stairs. Okay. Because that's one thing. Where is Nagmani Garu? She is also not here. Okay. Let's wait for a few minutes. Okay then. Okay. In the meanwhile, like the next big thing is like we had this feedback form. Okay, we kept it on the home page. Okay, on the BDA home page, you have the feedback form. All of you fill it. Okay, take from 5 minutes of time. Okay, and you can fill it. Okay, I already sent the emails. Okay, so email.
Very serious about the form being filled. If the form is not filled, you are not going to get your email.
For him, there is no problem. Okay. The interesting thing is for him, there is no problem. Okay. So that's about the feedback form. Okay. Yeah, if anybody want to talk about the conference, I mean, like you can give your feedback because like there is live recording and anybody has any comments or something. Okay. Experiences, etc. Okay, so that will take some time. Nagmani madam? Nobody want to come? For how many of you it is the first conference? For how many of you it is the first conference? You can tell about your opinion, isn't it? Who would like to come? So we'll just listen to one or two, okay? But who would like to be that? Chosen ones. Come. I mean, it's a great beginning. We would like to hear your opinion, okay? To be frank, this is the first conference I am conducting in India. For me also, like, it's a great experience. Okay, but at the same time, like, I want to listen to your opinion, okay? Tell your name.
Hello, I'm Anjali. I'm a third year student. I'm doing my UG at SVIT, and this is my first ever conference. It was a great experience. I learned so much, right? There's still so many things that, so many talks and so many things that have happened that I still need to sit down and process and think about and learn. What I loved the most about these experiences,
that have happened over the course of these 4 days is how engaged and passionate everyone seemed about what they were talking about. Because from my perspective, these are very niche, super specific concepts, and like people have spent years building the skill set to understand all of these things. But I just love how engaged and passionate everyone is about this, and I loved how welcoming everyone was, whoever I spoke to, and I there is a few things though that I really think would improve our experience. Like the next time if you were conducting something like this, it would be if we could have more references with regards to the tutorials, because sometimes I attended a few of the tutorials like yesterday and the day before, and there were issues with their system, so they weren't able to complete, they weren't able to finish some of their objectives. And another thing would be like probably if you could, if the speakers were interested, if they could just give a link to their references so that we can go back later and reflect on what they spoke about. So yeah, thank you.
Thank you very much for the feedback. Just to give a few answers to your suggestions, okay? Regarding the references are concerned, publications will be anyhow will be coming. Most of the slides I will try to put them online, okay? Down the line. It may take week, 10 days or 15 days. I'll send another mail stating like the slides I am putting. By default, I am considering like all of you agree for that one, I am putting the slides. If any of you have any objections, write me a mail. If I don't see a mail, then I am putting it online. Okay? I am already requesting the keynote speakers and then like the tutorial speakers and everyone, please send your slides. Okay? That is how like it is more beneficial for the community. Okay? Especially the community which has actually participated in this conference. Okay? That's how I am defining. Okay? If you have objections, raise it. Okay? Not after I put them online. Because once it is online, it's online. Thank you. Anybody else? If no one else, then I would like to say a few thanks. Okay, so the workshop chair. So Chinmaya Dehuri, can you please come? So single-handedly, like he has taken care of the workshop selection, conducting the workshop, and also like even organizing the TCS workshop. Not just that one. Wherever I couldn't fill the session chairs in the main conference, he was always my backup. Okay. So I was requesting everyone, but my plan jet was always there. Thank you very much. Thank you. Okay. So yeah. Okay. Okay. Then thank you. Thank you. Okay. You want to come? Come. I mean like. But okay. Yeah, okay. Yeah, I will like let us stand.
I don't charge per person.
At least not in BDA budget. Okay, thank you. Then
I'd like to first of all like thanks Satish. Like him, this is my also first time I'm organizing chairing workshops. I was not expecting that it will be so nice because I've been to other workshops and I know that what's the difficulties. But over here, the entire environment is completely different. The comments, some of the comments are really very harsh, but at the same time, it's very strong comments, very genuine comments. People are like really like the girl just before she said, they're like so engaged. This is what also like I observe that here audience is really very engaged. And I'd like to thank Professor Satish, my postdoctoral supervisor, and always be my supervisor, always be my mentor actually. Thank you very much for giving the opportunity. Yeah.
Thank you. Okay. So we take out the hats of University of Tartu Astoria. Welcome to India. Thank you. Okay. By the way, like soon he is going to join ICER Berhampur as the assistant professor. Okay, now you are competing with me. That's cool. That's good. That's actually good. Okay. Then, okay, I want to thank one more person. Okay. Finding a chair for one session was so damn tough for me. She handled single-handedly like 5 sessions. Thank you. 5 tutorial sessions.
Really good job. Sir, I look in other way. Finding an opportunity is a great difficult in this situation, and as a colleague and our professor, giving an opportunity for us is a learning experience. I thank for that thing, both Dean sir and the chair of the BDA, and really it is a good experience. And really, as a teacher, if we are chairing, we learn a lot, and we will bag a lot of problems so that we can guide properly and give a good challenging problem. This is an opportunity, sir. It's not a this thing. Thank you very much, sir.
Thank you. Okay. Did we take a proper photo with giving here? We had. Okay. Thank you. Okay. So then there are 2 more. Okay. So the last tutorial session.
Yeah. Last tutorial.
Professor. Yeah. This you will. Please. Okay, so you give to one and I give to another, and you be both this center, and then like okay, right. Thank you. No. Krishna Reddy garu first రోజే ఫోటోకి రండి మరి ఇంకేముంది మరి అలాగేదో నాకు ఇవ్వట్లేదు అన్నట్టు అక్కడే ఉన్నారు. కాన్ఫరెన్స్ అయిపోయింది. నేను ఇక బెస్ట్ పేపర్ అవార్డు అనౌన్స్ చేయలేదు, అసలు పెద్దది ఉంది. Thank you. So one last thing left, which I wanted to do from yesterday. Okay, somehow like it got postponed. We have not announced the best paper award. I would really like to have announced it yesterday night, but I couldn't. Anyhow, there would be okay. This is the best paper award. Okay. So as you know, like this is purely the effort of PC chairs. Okay. And then like again, Chinmaya jumped in and when one of the PC chairs wanted him to jump in. Okay. He was just reconfirming it, his decision. Okay. I mean their decision. So whether it stays the same or not. Okay. And this is purely PC chairs decision then, because like he gave the feedback and then like they are the ones who have taken the decision. The best paper award basically goes to adaptive temporal random walks for graph representation for Monachari and Professor Durga Bhavani. Okay. Unfortunately, both of them are not here. Both of them are on a competing conference. Okay. Yeah, why not? Okay. So
I'm the post box.
Bhavani ma'am, okay. No, but then like Dean is giving it, isn't it? Okay. Yeah, please. Okay, if you want. Huh? No, co-author now, scholar. Then it is better Dean gives it. Okay. That is the best. No. Actually, sorry to denying it, but the point is receiving that needs significant effort. Okay. You need to do that. Okay. Aim for it. One day you will achieve it. Okay. With this one, thank you. And then like with this formally BDA 2024 closes. There is tea outside. And then like thank you very much. Yeah. One photo. Okay. One photo with everyone.